So depending upon your geographical location, good morning, good afternoon, and good evening to all the esteemed guests, senior and young participating scientists joining us virtually from different parts of the world. It's a matter of great privilege for us to extend you all a warm and cordial welcome to the third day of the 18th International Online Conference on Mathematical Sciences for the Advancement of Science and Technology. In short, we call it MAST 2024, organized by the Institute for Mathematics, Bioinformatics, Information Technology, and Computer Science, having branches in Sweden and Japan. In short, we call this institute as IMBIC. Today, we are now having a technical session, especially this is a workshop on data science, accelerate your career. So already we have last 2 days we had 4 invited lectures and today we'll have 2 more. And we are happy to announce that we are having with us 2 eminent and very young data scientist leader, Abhishek Sengupta and Vishwajit Pal. So it's my great pleasure to welcome them. So the first talk will be delivered by Vishwajit. The title of his talk would be the Building a Winning Approach for Data Science Campus Interviews. So before that, may I just introduce him? So Vishwajit brings over 18 years of experience in delivering high-impact data science and data engineering solutions, product development, and consulting services, primarily in the retail sector. Currently, he serves as the Director of Data Science at Kluven, the Customer Health Division of Johnson & Johnson, where he leads the development of AI, Gen AI-based applications, and driving innovation at the GCC level. An AI thought leader and holder of 4 patents, Vishwajit has received numerous awards, serves as a guest lecturer at the Arizona State University, and actively shares his expertise through keynote, webinars, and publications. Vishwajit holds a master's degree in applied statistics and informatics from Indian Institute of Technology, Bombay, and bachelor's degree in mathematics from our own Presidency College, Kolkata. So without any further delay, it's my great pleasure to welcome Vishwajit. Vishwajit, the screen is yours.
Yeah, thank you, sir. Thank you for the great welcome, and thank you. And as sir mentioned, right, depending on from where you are joining, good morning, good afternoon, and good evening. So let me share my screen. Uh, Sir, is it visible? Sir, is my screen visible? Give me a second. Let me share once again.
It was visible a bit ago.
Okay.
Yeah, again, it's coming.
Okay. Perfect. Cool. I think sir has set up a pretty good context, and let me do some more context setting before getting into the the content of the talk. So I think essentially, like so far, you guys have gone through quite a lot of technical interviews, paper presentation, and all. And when I was discussing the agenda with sir, the sir mentioned that Vishwajit, can you take a session on how to get into this industry, right? And maybe campus interview is it's not only focused on the campus interview per se, but it's also about how to get into this industry, what are the skill set you need, how to grow, what are the different roles and responsibilities. So that's how I actually have shaped this particular talk. So what we will do in next 45 minutes to 1 hour, right? So I will give you a very high level overview of data science. Maybe some of the things might be repetitive for you guys in case if you are already aware. Then I will walk you through the different roles and responsibilities which are there in the data science industry. I think the major roles, because there are some smaller roles here and there as well, which I'll not be focusing on. And then I will walk you through that how to build a data science career. Okay. So how to do it, what are the skill set you need, what are the different repository you can refer to, and etc, etc. And definitely we'll have questions. So to make the session more interactive, what I'm going to do is after every segment, I will open up for questions, we'll discuss, and then we'll move it to the second segment. Okay. Now let's dive into the session. Now the first section, which is about data science overview, right? Now I think this is right now is the most talked about term in the technology world, artificial intelligence, right? So let's see that what artificial intelligence means and how exactly it ties back to our theme of this today's session, which is data science. Now this is a great, picturesque explanation of artificial intelligence and data science. So if you see, the artificial intelligence is basically the blue section, right? The entire gamut. Under that, the machine learning is basically the core of the artificial intelligence. So essentially, the machine learning, you can call it as a heart of machine of the artificial intelligence, and then go through each of them little bit detail. Deep learning is a specialized scenario of machine learning where it involves with neural network. Again, I'll go through it. And then finally, I think the most talked about concept under artificial intelligence at this moment is generative AI, right? Which is technically a subset of deep learning. Then here comes the data science. Now there is a huge overlaps between data science and artificial intelligence. But however, there are certain segments of data science which are outside artificial intelligence. Like, so I typically don't call it as a full artificial intelligence segment. I call it a partially, artificial intelligence segment. And this entire gamut of artificial intelligence depends on big data, right? So this is what the interpretability of this particular diagram looks like. So now let's go through each of them, each one of these component in little bit more detail. Now, what is artificial intelligence, right? It's a, I think most of you know the definition, but I'm just repeating a bit. So essentially, any machines or any system what you build, which will mimic human intelligence to a certain extent, is called artificial intelligence, right? So it's about a system. You build a system which mimics human intelligence, right? That is exactly what artificial intelligence is all about. And what it typically do, it typically do the task like reasoning, learning, decision making, right? So essentially you need to build a system which will cater to this kind of a task. Under that, and data science, I'll just hold myself for time being because I have a detailed slide on this. So then the machine learning. So machine learning, as I mentioned, is basically the heart of these entire artificial intelligence gamut. So this can consist of the models or the mathematical, the techniques which essentially help the artificial intelligence system to make decisions, make predictions. So that is exactly what the machine learning is all about. Deep learning is a special segment of machine learning which caters to a technique called neural networks. So anything related to neural networks in the machine learning falls under the gamut of deep learning. It also do the same thing what machine learning do, which is about making prediction and helps in decision making. Under deep learning, there is this new field which has come up called generative AI, right? And I'm sure that almost every one of you have used ChatGPT, so that is one of the classic use case of generative AI. What generative AI does is basically it is a particular machine learning, artificial intelligence section or area which helps to generate something, right? That is what the name generative stands for. And now what essentially it helps to generate? It helps to generate text, images, music, and obviously by using some of the data, right? And the last one, which is about the big data, these are basically it's basically the volume of the data, what we talked about, or different types of data which are needed to build this kind of model. And then also the real-time data, that do you need a data in a real time or you need data in a batch processing mode. So all these things, when typically when the data falls under at least one of these gamut, they're classified as big data. So there are this concept of 3 V's of big data: the volume, velocity, and veracity. Now obviously there are few more V's I've added, but those three are the fundamental V's of big data, right? So this is how the artificial intelligence gamut looks like, or the ecosystem looks like. And in that particular gamut, data science plays a very critical role. Now let's go to the data science, which is our main topic of discussion today. Now let me read the definition of data science, and I'll explain, and I'll mention, I'll tell why I've actually make certain words very bold. Now, data science is an interdisciplinary field, right? So first of all, the word interdisciplinary is very important. What it involves extraction of meaningful insights and knowledge, right? So basically data science extract insights and knowledge. From where? From structured and unstructured data. Now, structured data means basically a tabular form of data, and unstructured data means anything like text data, image data, sound, voice, anything related. Non-structured data are basically the unstructured. So your Facebook feed, your Instagram feed, all are basically unstructured data. And by how we want to extract the meaningful insight through main four key components: scientific methods, some processes, through some algorithms, and then by building systems, right? So essentially, data science, first point, is an interdisciplinary field. Second is basically what it is used for. It's used for extracting meaningful insights and knowledge. From where? Structured and unstructured data. And through what? Through scientific methods, processes, algorithms, and system. So this is basically, in nutshell, is the data science is all about. Now let's see what this interdisciplinary field means. So technically, if you see this particular diagram, data science is basically in the cusp of three main, the stream, knowledge stream, or subjects, you can call it. It's basically a mixture of computer science, mathematics, and statistics, and you need to have a very good business domain, because at the end of the day, what we do is basically solve business problem, right? So because this is at the cusp of three big subjects or big areas, that's why it is called, it's an interdisciplinary field, right? So this is how the data science things looks like. Now, so we defined AI, we defined what is data science. Now let's see that, how the data science market looks like. Now, if you see, I have taken this particular graph from a company called Business Research, who actually do a lot of market research around different segments. So what it typically says, right? So you see, we are at right now 2024, and the total market size of artificial intelligence, which is part of the, obviously the bigger set of data science, it's almost close to $100 billion business. And in next 4 to 5 years, it is actually projected to reach $200 billion with a CAGR of 23.2%. So what it entails to, right? What this particular graph says, it says that this is one of the fastest growing field right now, with a potential of around $200 billion market, right? So it's a huge number, right? So this is how the future of artificial intelligence looks like. Let me give you another interesting stat. So typically every big company have their shareholder meetings where the CEO of the company, talk about the performance of the company, what they are planning to do in the future, what are the big initiatives, and etc. And it's a big deal, because how that particular talk comes out determines sort of the stock values, the future of the company, etc., etc. How the market is actually seeing that particular company. So that is a very important sort of a meeting for any CEO, or for any market, any company standpoint. So if you see, in 2010 till 2015, 2016, in that shareholder talk or meeting, a CEO mentioning AI as one of the line items was almost close to 0%. So it was there. AI was there in the industry or in the company even that point of time also. However, from a CEO standpoint, it was not at the top of their mind, or in the top 5 or 10 things what he wanted to go out and talk to the shareholders, right? However, see the spike. 2016 or 17 onwards, and if you see the 2023 stat, around 16 to 17% of the companies, right, or basically the CEOs of the company, I've mentioned AI in their shareholder stock. That means AI actually have is part of their one of the top 5 initiative, if I can call it, right? So that's how, that's the rapid increase of the importance of AI at the industry level, right? What the summary of, or basically what is the takeaway from this particular graph is that if any initiative, if it is part of CEO's top line items, then you will get the funding. Then you will know that you are in the right place, right? In terms of the company, you are actually doing something which is directly impacting the top line or the bottom line of the organization. So 17% may be a smaller number at an absolute scale, but believe me, it sets a pretty significant number, because given the fact that for most of the time, uh, or most of the decade, AI was not part of, almost it was part of 0%, right? So growth, and I'm hoping that over the years this 17% will grow to somewhere between 30 to 40%, because it is playing a very important role for at a CEO level. So and I just wanted to quote. I wanted to show a quote from DJ Patil, who was basically the first US chief data scientist, and there is a professor called Thomas H. Davenport, who is a professor of Babson College and also was part of the MIT's AI forum. So they actually made this statement almost 10 years back, that data scientist is the sexiest job of the 21st century. I think it was quoted around 2012-13, if I'm not wrong, and it's still it's still relevant. So I just wanted to highlight that the future of data science or artificial intelligence looks very rosy or green. Now, this is from a world standpoint, right? Let's see what's there in India for us, because at the end of the day, we are part of India, and we need to understand the segment here. Now, in India, uh, there are a lot of global capability center which are being established in India, and by global capability center, I mean that, say your headquarter is in US. Say for example, a company like Walmart, which Abhishek is part of, or I was part. It was my ex company, and then my current company, which is Johnson and Johnson. They're all US headquartered company. However, they have established a global capability center in India, where we are part of, right? So if you see the number of companies who or global companies who are creating these capability centers in India, just see the growth. In 2015, it was around 1,000 plus. In 2023, it is 1,600 plus. And in 30, the projection is about there will be more than 2,500 all capability center. And believe me or not, in every week right now, one global capability center is being set up in India, be it in Bangalore, Hyderabad, Gurgaon, or any other place. And what it tells to, if you convert this into an employment, just see the growth, right, or the employment opportunities, right? It is zero point 0.7, almost, zero point 0.7 million in 2015. Right now it is 1.6, and then it is moving to 4.5, the projection, which is 4.5 million jobs in FY30. And if you see the market size, it is going from 20 to 46 to $110 billion. So this is a very lucrative space to be in. Now, if you see some of the GCCs, means obviously it's not possible to capture everything. You just see that every big company, every name, like you just name it, and you will have a global capability center in India, right? HSBC has a very huge presence in Kolkata. And if you see Samsung, Dell, Amazon, Apple, so you just name it and you will have it, right? Now, now this is about the GCC or the Global Capability Center, right? But what's there for us? Us means being an artificial intelligence practitioner, right? So if you see in the GCC, what are the top focus? So top focus, if you see the first two top focus, they are AI or machine learning and data analytics. And 80% of the companies who are setting up the GCC in India, their top focus are in these two areas, right? So you set up a GCC, it opens up a door for professional like us, right? And the other good key areas are like cloud computing. You can see a robotic process automation. This is an area where a lot of generative AI is getting used, and definitely the cyber security. So the summary of this particular slide is that, first of all, the future of global capability center in India is looking very, very prominent. And the top initiatives within these GCCs are mostly revolving around, the AI, data analytics, and cloud. Obviously, there are other areas, but I'm saying that these are the more prominent areas, right? So what we did, we defined the market. We defined that, hey, how a data science in India looks like. Then what are the different industries which uses data science? Now, right now, to be very honest, it's every industry. There is a simple answer to this question. Right from manufacturing, transport, logistic, BFSI, high tech, healthcare, retail, CPG, you just name it, and almost 95% of the company will have data science team in some form or shape. Someone will invest more, someone will be investing less, but I don't think that there are very, very few companies we don't have data science team right now, right? And there are hell lot of use case which these companies are solving. I just wanted to highlight few of them, like for example, fraud detection, that how to detect the transactional fraud or basically any fraudulent customer. We use data science. Predictive maintenance, this is a classic use case of from manufacturing industry, that there are a lot of machineries, and what is the right time. If we can actually predict beforehand where the maintenance are needed, it actually saves quite a lot of cost and downtime. In the healthcare domain, disease prediction and diagnosis is a very lucrative area at this moment. A lot of research and a lot of work is being happening in this. Demand planning is a classic, time series forecasting use case, which is there since ages, and still it is one of the most sought out, use case in the data science industry. Followed by inventory management, dynamic pricing, self-control car, and etc. So, and Abhishek will walk you through the personalization use case in the next half. So, just a quick snapshot of how data science is being used in our day-to-day life. Means you might not you might not be realizing it, but actually you are using artificial intelligence or data science in a lot of day-to-day activities. Okay, so let me give a couple of examples. Now I'm sure that you guys have you did shopping from Amazon or Flipkart, right? I'm 100% sure, right? I think almost every one of you. Now, this is basically a snapshot of a board game. This couple of days back, my daughter's birthday was there, so she wanted this particular board game. Now, if you go to the any product landing page, right? For example, this is a Gold Crush. This is a board game. So you see, if you scroll down, there are two areas which you typically see. One is a frequently bought together, that along with this Gold Crush board game, what are the different board game does the customer buys? And then there are areas like, related to these. So along, who are the customers who are buying this particular Gold Crush? Which are the other product these customers are buying, right? Related to this. So these two is basically our totally outcome of data science algorithms, right? And some of the algorithms which are being used in order to generate this outcome, which Amazon do or even Flipkart do or any e-commerce site do, are association rule mining, collaborative filtering, matrix factorization, and collaborative filtering and matrix factorization in detail, Abhishek will cover. And there are other methods like based on graph, which are called graph neural network. We have sequence-based models like Markov chains and RNN, and deep learning model like neural collaborative filtering and others. So what I wanted to convey in this particular example is that how exactly AI is getting embedded into our day-to-day life, right? And maybe some of you might be knowing, but for most of you guys, this is in the back end is what the data science or machine learning or artificial intelligence, whatever you can call, is the backbone. Second example, which I am sure that all of you have noticed. So if you if you have Gmail account, you can see now there are three segments, right, where our emails get categorized. So moment email comes in our inbox, it typically categorizes into either it goes into primary, or it goes into the promotion section, or in the social section, right? Again, the back end of this is basically data science or machine learning. And some of these, some of the methodology which are used to do it are naive-based classifier, logistic regression, neural network, and support vector machines, because this comes under a genre of machine learning called classification. So if you see, like, again, this particular use case, everybody has seen it. The backend is machine learning. So with these two example, what I wanted to demonstrate is basically that, and there are so many other use cases on a day-to-day basis where we actually are using machine learning or data science or AI. Maybe we are aware. In some cases, we might be aware. Some cases, we might not. But eventually, this data science has right now has become a very integral part of our life. So quickly, just to summarize, we started off with AI ecosystem, right? And then we went and defined the data science definition. And data science definition is about, it's an interdisciplinary field, right? It is mostly used for knowledge and for insights on structured and unstructured data using scientific algorithms, processes, and system, right? And then we moved ahead. We actually showed quickly that, how the data science market looks like globally, then what's the state in India, and then we also covered the different use cases, right? Which are the industries which uses the data science, which are the different use cases, and then we showed a couple of example from our day-to-day life. I'll just pause for a minute to take some questions if you have any.
So any questions? Please, those who are in Google Meet link, can please unmute yourself and ask the direct question. I will check for anybody from YouTube link. Any question till now? Those who are in YouTube link, do you have any question? Then I will convey it. Okay, maybe you just continue. I will
Yes.
collect the question and I will let you know.
Sure, Abhishek. Yeah. Cool. So let me move to the next section, right? Now we defined that we have a pretty good understanding of this data science world.
Just a minute. One comment came like, sir, can you explain slide 6 once more?
Slide 6. Okay. Yeah. So yeah. So what it says, right? So the graph on the left side actually says that what the global market of artificial intelligence look like. So in 2024, the total investment is basically around $100 billion, the projection is it will go up to $214 billion by 2028, right? So it is the entire investment is going to go up. That is what essentially the market size or basically it denotes. What the right side it says is basically that in the shareholders earning calls, in what percentages of company AI is getting mentioned. And in the shareholder earning call is basically the calls where CEO address to all the shareholder about the performance of the company, what are the future plans, what are the top initiative they are working on. And in that top initiative, almost 17 to 18% of the CEOs are calling AI. And why I'm telling it, because it's a very, very big deal, because CEO doesn't call all the initiatives which are happening in the organization, right? They only will call the top initiatives which from where the maximum value are, hopefully they will achieve it. So that's what their plan is, right? So that's why like in the earnings call, getting a line item is a very, very big deal in the industry. And in this case, AI is is featuring as one of the line items for almost 17 to 18% of the CEOs right now, compared to which was there in say 2014-15, which is almost close to 0%. So that is what this particular slide referred to. Cool. Let me quickly move to the next section. Now, let's talk about the data science roles and responsibilities, okay? So what are the different roles are there in the data science industry? Now, one of the definitely the primary role, which mostly me, Abhishek, we all are part of, is data scientist. So what a data scientist do? A data scientist typically is responsible for developing the algorithms and models, right? And by models, I talk about quite a lot, right? We talk about neural network, we talk about naive Bayes, we talk about support vector machine. So all those model, who the responsibility of data scientists is to build it, right? Second is definitely it's also about how we are conveying the outcome of the model to the business, because at the end of the day, we are solving a business problem, right? So we have to convert the outcome of our model, which are more mathematical and statistical, into a form which business will be able to understand. So though these are the two main, the responsibility of a data science at a very high level. Then comes the machine learning engineer. Now what the machine learning engineer do, right? Now just imagine, say for example, I'll take the example of Walmart. Now Walmart US has almost about 4,000 odd stores, and say you are building a model on demand forecasting, which is about time series forecasting, right? So it's not about building a model for 10 stores here. I'm talking about building a solution for 4,000 odd stores, right? So so what it entails to, so data scientists will build the model, build the algorithm. However, you have to scale it, right? You have to scale the algorithm to 4,000 stores. So machine learning engineer, along with, in tandem with data scientist, will help to scale that particular solution, right? In this case, from 10 stores to say 4,000 stores. They will help to implement that solution into the the life system. They will help them in terms, what that process is called deployment. And obviously it will, and they will help, they also do day-to-day tracking of the entire pipeline, and the pipeline means the end-to-end process, right from ingesting the data, running the model for 4,000 odd stores, then storing the result somewhere, integrating that result into some other product, and then so that end-to-end pipeline they are responsible to maintain on a day-to-day basis. So machine learning engineers play a very vital role in this entire scheme of things. Next comes the data engineers. Now data engineer, because you cannot build model without data, right? So what data engineers do, data engineers actually extract data from the source system. Say for example, in this particular case we are talking about sales forecasting, so we get the data from, say, point of sales systems, and there can be inventory management system and so many other systems. So what data engineer will do, data engineer will extract the data from this all these system, put it into one place, and clean the data, so that from that particular place data scientists can start getting yielding the data and build the model, right? Now the point is, there is a say in the ML world, garbage in and garbage out, right? So if your input data is wrong, then whatever model you build, the output will be wrong, right? And hence the role of data engineer is very, very crucial, because they are responsible to maintain that clean data, basically to bring and maintain that particular clean data, right? So that is what the data engineer role is. Then comes the data analyst. Now what data analysts do is basically they are also important like data engineers. So they actually analyze data. They don't build anything predictive, right? They actually analyze the data, whatever has happened in the past, and then based on that they create certain insights. So it's more of a backward looking, but those insights are leveraged by the data scientists to create something which is predictive or more perspective. So essentially the insights which are coming from the data analyst are very critical, because those act as features when you are building the model, when as a data scientist, when you are building the models, right? They also play an important role post modeling, because once the model is deployed, as I mentioned the machine learning engineer section, so obviously we generate a lot of insights, right? And then data analysts also analyze the results, that what kind of results it's coming out, whether it is making sense or not. Maybe it is making sense in certain segment, it is not in other segments. So all those kind of a work is done by the data analyst. The fifth role, which is very important, is a UI UX designer. So what they do is, obviously, data science is not about just building algorithm for 10 store, as I mentioned, right? So at times we have to build product, standalone product. Now, when you're building a product, right, you need designers, right? Because at the end of the day, the business will interact with the product, right? The algorithm and everything happens at the back end, right? But the business is going to interact with the product. So if your UI UX is not strong, and if your product keeps on failing, then obviously, it is not going to work, right? Say for example, again, let me take that Amazon example. If you typically, as a customer or consumer, we don't interact with the personalization algorithm which is running behind, right? What we do is basically we open the website amazon.in, and then we do our shopping, right? Whatever recommendations are coming, it's in the back end. But if suppose, if the the look and feel of the platform is bad, you are not able to search, you are not able to find where that particular frequently bought item is, right? Or maybe once you are clicking, it is taking a lot of time. So then definitely it's a very bad customer experience, and that is what the UI UX designer do. They ensure that there is a proper customer experience happening. And then the product managers, because at the most of the work what we do, at least me, Abhishek, what we do, we actually build ML products, right? As I mentioned, that it's not about solution. Only solution is about catering to 10 stores. But when you actually building a solution for 4,000 odd stores, we need to build products, and that is what the product managers do. So the product managers are sort of a non-tech people, but who actually sort of integrate all these different roles, right? Data scientist, machine learning engineer, data analyst, UI UX, and then so that eventually one product can be built. So it's a very important role because he holds the fort, right? Now let's go deep a little bit on the data scientist, because that's the that is all about the talk about, right? About how to create the career. Now, if you remember, right, when we define data science, how did we do it, right? So we actually said that data science is the process which are involved in data science are scientific methods, processes, algorithms, and system, right? So essentially, a data scientist uses these tools on structured and unstructured data. Again, tying back to the definition of data science, eventually what they do is to generate insights and knowledge, right? So it's a no-brainer that the data scientist is someone who actually follows the entire process of data science, right? So, and that's why this is very similar to the data science definition. There is a person called Josh Wills. He actually quoted a very interesting thing to define data scientist. So data scientists are the sort of the person, him or her, who are better in statistics than any software engineer and better at software engineering than any statistician. And that is where the essence of interdisciplinary come into the picture, that you need to be good in mathematics and statistics, you need to be good in computer science, because you need, and then and this particular role is on the cusp, right, along with the business. Now, what are the core skill set? And I'll define the core skill set in two halves. One, technical skill sets, and another are soft skills. Now, as I already mentioned, that it's an interdisciplinary field, so we need mathematics, statistics, programming, and a business knowledge, right? So this we have already talked about. However, there are a lot of soft skills what are needed. Number one, because it's a problem solving skill, and let me combine the two. Because it's a problem solving skill, first of all, you need to have a good problem solving ability. And believe me, most of the problem what we solve are not a single problem. Most of the problem are complex, and we typically break them into sub problems, and we solve sub problems, and then which finally tie back to the bigger problem. This tie back to the curiosity and continuous learning, because first of all, there are no set rules in most of the times. Most of the times, yeah, we have to read, and then we have to see that what are the things which are useful for our use case, right? So there is a continuous learning element is there, and given the fact that this particular field is so evolving, in generative AI every week something new is coming at this moment. So So there's a high amount of continuous learning or learnability is required. If you don't learning continuously in this particular field, then it's difficult to grow. Third is about communication and storytelling. Now, given the fact that, as I mentioned so many times by now, that we solve business problems, and typically our job is to build the solution or build the models and convert them into a form which can be consumed by the business. So that is where the communication and the storytelling part becomes very critical, because you need to understand that we are converting some mathematical output into a form which business can understand and take action, right? So there is a good amount of communication skill is needed. It's not only about how good you are speaking English, but it's about how good you are able to translate the outcome to a person who doesn't understand anything around mathematics or statistics, but he's able to consume it. He's able to relate that how these numbers will help him or her to grow his or her business, right? So that's why the communication and the storytelling becomes a very critical role. And lastly, collaboration skill, because in the previous slide you got to know that there are so many different roles are there in the data science world, right? So when you are actually building a data science product, you will be part of a squad which will have data scientist, machine learning engineer, data analyst, UI UX designer, and product person. So given the fact that it's not about you will only interact with the data scientist team, that's it, and your job is done. That's not the way it works, right? So you have to interact with everyone, and everyone is coming from different skill set, different backgrounds. For example, the product manager is mostly a non-tech guy, right? So you need to learn how to collaborate with so many different kinds of people, different kind of profile of people, so that you finally achieve the desired goal, right? So technical skill, mathematics, statistics, programming, business knowledge, and the soft skills include the curiosity and continuous learning, problem solving, critical thinking, communication, storytelling, and collaboration skill. Now, one of the most interesting part, data scientist career path. So how the career looks like for a data scientist, right? So typically the data scientist in designation wise, also data scientists start from the freshers, from the campuses. People get hired even from the outside of campuses also, people start their journey. So typically the segment spans between 0 to 5 years, and there are a lot of different designation like associate data scientist in different company. You follow different nomenclatures. So what they typically do, as I mentioned, so they actually try to understand the business problem. They do a lot of data cleaning, convert them into features, they build model, they create some graphs, and then finally they communicate the results, right? Uh, right now, I'm talking about the base salary. On an average, a data scientist gets somewhere around 12 lakhs. Obviously, I'm talking about base, and on top of that, there are bonuses. Some companies provide stocks, so obviously the numbers increases, and it's on an average I'm talking about, right? So once the data scientist is done, then you move to senior data scientist, right? Typically, the senior data scientist ranges between 3 to 8 years, typically. What they do now, obviously, the fundamental responsibilities of data scientists are there. Along with that, you can call it, they actually start leading the data science initiative. So you can call them as a tech lead, right? So they are now leading the initiative along with a group of data scientists, right? So that's how the senior terms comes, right? And more or less the roles and responsibilities, the skill set remains the same. If you see the average salary, base salary is around 20 lakhs plus minus, and plus on top of that, all the other components are there. Then comes the staff and the principal data scientist. So these are basically a mid-senior to a pretty senior guys. Principal is a pretty senior role, which right now Abhishek is playing in Walmart. So what they typically a principal scientist do, they also work very closely with the product and the business team to identify the problems where data science or AI techniques can be used, right? And then along with, definitely he's responsible for the delivery with along with the senior data scientist and the junior data scientist. Along with that, they're also responsible for driving some of the publications, patents, and definitely provide mentorship to the junior folks, right? So that this is where a lot of research element comes into the picture. and along with definitely the execution. Typically, on an average, you get 30 lakhs, very average, and the range is pretty wide in the industry. I just took an average and got the data from the internet. Now comes the leadership role, right, in data science. The leadership role start off with data science manager. Uh, and as the name suggests, and typically the span is between 10 to 15 years. If as a manager, he will start leading a team of data scientists, right, and will be responsible for delivering the data science solution, and also to collaborate with multiple stakeholders, right, as I mentioned, with the data engineering team, the design team, the product team, and etc. etc. It's on an average it is 40 lakhs, and obviously it varies quite a lot. Then it comes the senior leadership roles, which is basically comprises of director and VP. So typically it's a 15 plus years of experience. Typically that's how the industry definitions are. In this role, you start heading the division, right? Either you can head the data science team, or a lot of places, or the entire vertical as well, depending on the size of the company or size of the data science team. They collaborate quite a lot with the senior leadership, which include the CXOs of the company. Try to see that how can AI be part of their goal, and what are the different problems it can be solved using AI at a CXO level. They're also responsible for getting the budget for the team. So all those, the hardcore leadership work they do, along with definitely they also play like an SME or technical expert along with the principal data scientist, and chime in whenever needed while problem solving. Um, Typically, the base salary on an average lies from 60 lakhs, and sometimes it goes more than a crore as well. So that's how the data scientist career path look. If you see the left hand side of this particular line are all individual contributors, and the right hand side, as the name suggests, are basically the managerial and leadership roles. Okay, so so just to summarize, so we define the roles and responsibility, different roles and responsibilities of the data science industry. The core roles are data scientist, machine learning engineer, data analyst, UI UX designer, and product managers. We talked about, obviously the data scientist career path, and what else? What are the skills needed for becoming a data scientist? The technical skill along with the soft skills. I'll quickly pause again for the questions, and then I'll move to the last section of my talk.
So those who are in Google Meet link can unmute yourself to have the question. And I have few questions that I'm going to read. Chinmoy Ghosh, Dr. Chinmoy Ghosh, he's saying that mathematics students are the most suitable for ML-based jobs, but they're not properly motivated. What type of training is required for a students after his or her MSc in mathematics to get such a job?
Brilliant question, sir. And I'm sure that I can see a smile in Abhishek's face, because right now I think myself, Abhishek, are involved in that initiative in Presidency College. So what essentially, sir, we are doing is, and some of the areas which are extensively used in machine learning, as you correctly mentioned, are linear algebra and calculus, right? And I think when Abhishek will walk you through some of these concepts, you'll see a lot of this application. So essentially, the way we are trying to motivate in Prezi is basically tie back the theoretical knowledge, whatever they're learning, with the practical applications which are there in the industry. And I'll give an example of principal component analysis, right? The foundation of principal component analysis is eigenvector and eigenvalue. So essentially, when you are learning, or when a student is learning an eigenvalue and eigenvector, if we can tie with that, saying that, hey, this is how it is getting in the industry. Say, for example, a lot of this, what I talked about, right, in the back end, there are a lot of PCA things happens. So when they are able to tie back whatever they are learning along with the practical applications, then I think the motivation will increase quite a lot, right? So that's the I think initiative what we are trying in Presidency along with Abhishek sir.
Thank you. Yeah, so we have already taken some initiative. We are trying to include few of the data science courses, because already the prerequisite like linear algebra, probability, statistics, And of course, the uh, real analysis are already within our syllabus, but we try to look at the same thing but in a different angle. So from this year, we are trying to have a course, on a small course, which will give uh, a kind of brief idea about data science, a kind of exposure course to the students, so that they get at least some feelings about how this theoretical things could be applied there. Okay, so I have some other questions like, with evolving technologies, do we see certain roles, for example, data analysis become obsolete or merging with others? What's the future of this industry?
Oh, great question. Uh, so it's a great question. So see, my short answer is absolutely no. What essentially it's going to happen is these roles will be all these AI tools or the Gen AI tools which are coming into the picture right now will help the data analyst to carve out a lot of non-value activities what they do, and able to they can also focus more on some of the more value added activities. And I'll give you a small example, and I think this is the same use case which me and Abhishek are working on different companies though. like uh, like right now a lot of analysts use a lot of dashboards to extract information. And dashboard means, say for example, I want to understand sales of, say, Amazon India in Kolkata, right? So what essentially the business leaders will do, our analysts will do, they will go to a certain sales dashboard, pick up that number, and will report to the leader. Now what we are trying to do using generative AI is that, can we have a chatbot where where the leader needs to just type it, that, hey, what is the sales of Amazon in Kolkata last month? And instead of referring to any dashboard, he will give you the answer. Now will it impact the job of data analyst? Maybe not, most likely not. But what essentially it will help, that data analyst will be able to more focused on getting the insight rather than just spending his or her time to extract this kind of information. So you can call it that AI will assist them. That's the way we are calling it, AI assistant, to make their work much more simpler, and then so that they can actually invest a lot of time on the more value added activity.
Thank you. If the answer is clear to you, you can write it, type it here, or if you have more questions, then you can also type it here. Okay. Another question is, it's not a question, but might be a comment by Naga Sunil Kumar. It says that nowadays every engineer is a data scientist.
Yeah.
Okay. So,
Okay.
so another question. I think already Vishwajit has already explained. He says that, sir, can you explain how maths algorithm work with machine learning?
Yeah. I think I gave the example of the PCA just as an example, right? That how linear algebra is tied back to some of these algorithms.
Okay, and many of the requests are, how do I get this PPT of your
Oh,
presentation?
yeah, I'll share it definitely with you, sir, and we can actually see how we can expose it to the broader audience.
Okay,
Yeah.
so maybe in the next
Uh,
session there would be a lot of,
yes. Right,
and
right.
we will discuss
Hmm.
maybe in the in the valedictory session, or even at the session of 8 p.m. we will discuss how this could be shared and how the certificates would be distributed, etc.
Yeah.
So the question is, sir, why Python widely used for data science and AI/ML instead of faster languages like C++ or Rust?
Yeah.
Wouldn't be performance benefits and high-level abstraction of C++ make it more advantageous than Python?
Yep. So basically, to answer your question, that, see, one of the reason why, and again, I have used C++ quite a lot in my IT days, so I am totally aware. So Python, one of the advantage of Python is basically the ease of use and the easily you can learn it, right? Compared to a C++, because as you know, right, C++ is not an easy language to learn per se. And then even the Python will have object oriented thing as well. So that's number one. Number two is, I think the the machine learning model repository in Python is the best. The SciPy library, which is there, right? It actually, and along with R, obviously. So R and Python are best suited for this, machine learning work because of the library availability. For C++, for example, if you have to, say, do a XGBoost, right? You have to write it from the scratch. But in Python, there are a lot of libraries readily available, so you don't have to break your head on that. right? So that's how it make faster. To add, and one more point I just want to add, that nowadays when I talk about that scaling part, right, which is done by machine learning in engineer, so the Spark is being used a lot along with Python. So that's a segment called PySpark. So that is where the parallel computations are used to make it faster and scalable. I hope it answered your question, Sabyasachi. And Neha, your question, how to become, I think I'll jump into the next session and you might get the answer there, how to create the career.
Okay, till now,
Yeah,
no more question from YouTube. So please carry
sure.
on to the next session.
Absolutely. Yeah. Thank you, Abhishek. Perfect. So let's jump into the last section of my talk, which is about building data science career, right? So we talked about data science, we talked about AI, we gave overview, we talked about the roles and responsibility, and now how to create a career out of it, right? First step, the learn to code. So you have to learn how to code. That's a very, very first step. So the major thing is Python and R, as I mentioned, and ties back to the question which Sabyasachi asked. I think one of the reason it is actually so famous is basically because the modules, right? Both R and Python. It's basically designed for the statistical and the machine learning work essentially. So you can do a lot. You can write modular code, reusable code. You, as I mentioned, right, there are a lot of data science modules pre-built like Pandas, NumPy, scikit-learn, Matplotlib. And there are a lot of documentation available. There are a lot of, like open source communities available. And you can actually do a lot of version control. Now, what I'll do is that I'll put resources. Now, I'm not putting the same resources everywhere, but all the resources which I'll be mentioning in the subsequent slide, you can get anything and everything there. Is just to increase the number of resources so that you guys can actually explore based on your need, right? So one of the key resources in this is Data Camp. You will get a lot of courses how to learn Python, R in this particular, the platform. Again, other platforms are there, and I'll mention it in the subsequent slides. Now, once we learn how to code, right? Then comes the mathematics and statistics, which becomes the foundation, right? And I don't have to say anything. So what it helps, right? It helps in right from dimensionality reduction to building solution, because it's based on data, right? So every data starts off with what kind of distribution it entails to. Then definitely there are concepts around random sampling, and it's like it's a wide, very, very wide topic. But eventually, what my point is that the mathematics and statistics is the foundation, and after coding, you definitely need to have a good foundation. Resources, Coursera, again, Data Camp also have, but Coursera is one of the primary place where you can learn the mathematics, statistics, and the machine learning courses. Uh, Various US universities have their courses here, so you can go and check it out. A lot of specializations are also there. Then once you are comfortable with mathematics and statistics, then you can actually talk about the data transformation and exploration, because at the end of the day, and that is and one of the primary code skill set here is SQL. I know SQL is an old language, but believe me or not, SQL is still the foundational language for any data manipulation or data wrangling. So because it's a data related field, so you need to learn SQL, how to do transformation, how to extract, how to do all this backend stuff. Definitely, there are concepts like Hadoop. I talked about big data, right? So entire big data is based on Hadoop. Then there are MongoDBs and different DBs. So you can, again, Coursera, DataCamp both have this SQL courses, Hadoop courses. There is a resource also called W3 Schools which provide that as well. So you started off with learning coding, then you actually learned the foundation, which is mathematics and statistics, and then we moving on to the data exploration or data transformation, right? Once you are comfortable with that, then you are getting into the core machine learning, right? So machine learning is all about these are all the Python libraries, NumPy, Pandas, scikit-learn. So this is where you can talk about the feature engineering, dimensionality reduction. You build the model, how to validate it, how to explain the models, and etc. Again, Coursera, Udemy, DataCamp are the top three resources which are available. And also YouTube. YouTube again is a constant. Anything and everything you get it in YouTube. But for us, for example, for practitioners, we actually do a lot of courses from these three platforms, quite a lot. Um, then once you have a good understanding of the machine learning, then you need to have some understanding or some hold on the data visualization, because if you remember, I also mentioned that we have to convert the machine learning outcome into business language, right? That is where the data visualization tools become very important. There are two very common data visualization tools, Tableau and Power BI. You don't have to learn both. If you learn, even if you learn one, that should be okay. Again, a lot of courses are there in Udemy. Good courses are there in Tableau, because I myself have taken a couple of them. There are some student version of Tableau, I think, is free, so you can always download and practice how to do it. Very handy skill set for data scientists, and a very key skill set if you wanted to go into the data analytics field. So once you have the good grasp of data visualization, then you can go to the big data technologies, because as I mentioned before, right, that everything what we do is top of big data, right? So I just now, in one of the answer I mentioned about Spark, right? Because if you want to scale the machine learning algorithms to say 10,000 stores, 5,000, product, you cannot do it only using Python. You need to have Spark, which is the core of parallel computing. So that is where the PySpark, Python plus Spark together comes into the picture. And then Hadoop is about the big data technology, right? So because at the end of the day, when you have to scale the solution, when you have to deploy the solution, you need to have a good grasp of these technologies on big data technologies, right? Hence, and PySpark and Hadoop become critical. A new resource, O'Reilly, very good resource. And to be very honest, you can get a lot of paper also here. O'Reilly is very famous for that. So again, you can get big data again in Coursera, Udemy, DataCamp as well. I'm just adding one more new resource here. The last and final step is about cloud, because like everything nowadays what we do is on the cloud, right? Most of the companies, right? And there are three major clouds. One is Amazon cloud, which is called AWS, Amazon Web Services. The Microsoft cloud, which is Azure, and the Google have the GCP. So because everything what we do is on cloud, so having a good understanding of cloud computing will help. You may not need to be a master in this, which is absolutely fine, but understanding the basic concepts will definitely help to do in your day-to-day work, right? So again, Udemy is one of the very important resource. So just to summarize, you need to start coding. That's the first step. Mathematics and statistics foundations are basically it's a foundational knowledge you need to have. Then you need to learn how to do the data manipulation, data extraction, data wrangling, because without data you cannot do anything. Then you get into the heart, which is machine learning, right, along with deep learning and etc. And then you go to the data visualization, which is about how to explain the model output in a way which business can consume. Then having a good understanding of the big data technologies is important, because at the end of the day, if you have to scale the solution, you need to have an understanding of that. And finally, obviously, in terms of the cloud. Now, if you ask me in terms of the campus hire or campus fresher, do you need to do all these things? You might not. Some understanding will here and there are good, but I think if I have to pick three, then I think coding, mathematics and statistics foundation, and machine learning. These are, I think, the three main thing what you need to prepare for a data science campus interviews. Rest of the things, if you have certain understanding or an idea, definitely will help in the interview. Say, for example, if interviewer get to understand that you have a good understanding of cloud computing, that will definitely add value. But if I have to pick up three, it will be coding, mathematics, statistics, and the machine learning. Now, very important thing, how to build a portfolio, because at the end of the day, in today's world, only knowledge doesn't serve anything, right? It's one of the steps, but you have to also showcase what you know. And that is where the portfolio come into the picture, that it helps you to essentially showcase your skill set, right? You may know great, you may know a lot, but if no one knows about it, then what's the point, right? So definitely, along with knowledge, we also need to learn how to showcase that knowledge, right? And say, for example, this kind of a platform, right, where we are showcasing our knowledge or our technical knowledge, technical things, it helps to build our portfolio, right? That's why we are doing this kind of a sessions. It also helps to get connected with the, the current AI data science professionals. um, and definitely, like for example, and as I mentioned somewhere, that it's an evolving field, right? So the curiosity mindset should be there. Now when you are actually in a evolving field, you need to also try to understand that, hey, what's happening in the world, right? Where we are heading towards, what is this new AI trend, and etc etc. So it is very important to be part of a network, right? And definitely the last point is, the portfolio enhances your chances of getting a job. Now how to build this portfolio, right? So the first and foremost is LinkedIn. It's right now, it's a bare minimum, I can say. So you need to be part of, you should have a LinkedIn profile. You need to be part of it, part of a different groups which are there in the LinkedIn. If you can contribute, very good. If you're, even if you are not, then at least you should go through it on a daily basis to understand which are what, in what direction, in which direction the world is going towards. What are the things I need to prepare? What are the things people are talking about, and etc. For professional like me, or even Abhishek, who has spent like a decade, almost more than decade in this particular industry, after that also we spend almost half an hour to 45 minutes every day in LinkedIn. That's that, so that we are still relevant. Second is about GitHub. So GitHub, what essentially GitHub helps is, you can actually um, uh, host your projects in this report. It's a repository. You can actually host this project in this repository, and it can be accessed anyone. So for example, when we as a hiring manager want to see, and if we have a GitHub link pasted, or we have the access, then we can understand that, okay, what how the that particular candidate is solving the problem, how they are writing the codes, right? What are their codes maturity level, and etc etc. So having a GitHub link is a very important thing. Then Kaggle. Now Kaggle is basically a platform which actually for data science competition, is started off with data science competition, but along with the competition, you can actually do a lot of pet projects there. There are a lot of data available in Kaggle. So there are I think thousands of data repository within Kaggle which are publicly available. So even if you want to do your personal project, personal research, you can actually refer to the Kaggle data as well. Along with, definitely, it is a great platform for data science competition. So there are a lot of competition which is run in Kaggle. Some are practice competition, some are, you get, if you finish a top 10, top 20, you get rewards, and etc etc. So this is a great place where you can actually go and practice, right, whatever you have learned on live stuff. And the last one is Medium. It's basically a blogging platform where you can actually write articles and write blogs on the data science or AI or any tech related stuff. What it will help is, basically, it will give a better reach. It will help also to showcase your understanding, your skill on this particular subject, right? So LinkedIn, GitHub, Kaggle, and Medium, these are the four major thing or platform which are necessary to build your portfolio. So just, and I think I'm almost about to end my talk. Just a quick, a sort of a cartoon representation of what I meant, right? So getting a job is like entering a club. So what do you typically do, right? When you enter a club, you typically stand in a queue, right? And then you stand in a queue, and then you wait for your turn. Now this is exactly what happens, right? You actually share your CVs, right? And then you expect that the call will come. But you know what? The main crux is basically not that. It's very difficult with the second part. So typically, even in the club, when you want to quickly get into, if suppose some of your friends are already there, the bouncer in the guest list, you might know the bouncer. You can easily get into the club, and that is what essentially a portfolio is essentially does, right? So personal portfolio, very very important. You need to use platforms like LinkedIn, Kaggle, Medium. Networking, because if you know someone, say in this particular cartoon, in the guest list, or the bouncer, you can easily get into that very quickly. So you need to have a proper network who can actually refer you in your company. And definitely for a campus hire or the students, internship is a very very good way to get a job or get into the company, because typically what we prefer is interns who come and work with us, so that we can actually judging someone not on a 1 hour interview, but at least we have couple of months to see how he or she is performing. So internship is a very good segue to get into the in this particular world. So with that, I'm ending my session. Any question?
Okay, that's a wonderful session. So I'm sure that there must be a lot of questions. I can see a few of them are on YouTube as well.
Yeah.
So can you please, like Shurajit Mojumdar, his question is, what is the main data structure a beginner enthusiast may focus on?
Yeah, so it should be structured data, Surajit. You start up with the structured data, which is basically the SQL database, all those things. You can actually try it out, and then followed it by the text, and then after that you can go for the vision.
Okay, so another question by Shati Mukherjee. Through which academic courses one can be associated with AI, machine learning, data scientist career after doing MSc in mathematics?
First of all, I think MSc in mathematics is good enough, but if you want to do some specialization, I think every top institute right now in India is providing it. Be it IITs, IIM, BITS Pilani, even in the US colleges as well. So I will suggest that if you wanted to do from US colleges, you can actually refer to Coursera, because Coursera have a lot of specialization from Harvard, MIT's, uh, UC Berkeley, and others. So you can refer there. If you want to do it from India, you have courses in ISC, IIT, IIMs. You can just do Google and you will get it.
And the CMI course is also quite
Yeah,
good.
yeah, sorry, yeah, CMI course is also there, absolutely. Yeah, thank you for pointing out.
Yeah. So another question is, sir, how those hardware renting take place in cloud?
Hardware renting. So you can actually go to the AWS or GCP or Azure, and you can actually create your account. What I know is basically if you're a student, you will get some free credit, obviously to a certain extent. So using that free credit, you can do a lot of your personal projects. But after a certain point of time, if you need more credits, then you have to obviously go with a subscription. Personal subscription are there, enterprise level are there, so you can refer to that.
Okay. And Shubhusachi on the Google Meet, what are the important topics in statistics that I should?
Everything because this is eventually a statistical field. So I think right from like first year, right from your distribution to interpretation to modeling, everything essentially. And okay, sir, what by I mean array, linked list, trees. Shurajit, I think array is definitely one important. Linked list is also um, uh, means with nowadays a graph algorithms are actually very popular, so you can also go with the tree. So by data structure, okay, I'm getting your question. So data structure, yes. This array, linked in, all the basic data structure concepts are important, Shurajit. Yeah, data structure is, I'll not say it's a must for data science, but right now, given the fact that a lot of these ML engineer jobs are coming, which are actually helping us to uh, scale up the machine learning algorithms, that is where the data structure becomes very critical. So,
Okay. Another question by Amandeep Singh. It's how unstructured data can be made valuable and understandable in data science.
uh, I think the one answer I'll give, Amandeep, that is is ChatGPT useful to you? If it is yes, then that's how the unstructured data is useful. But a hell lot of use cases are there. Like for example, the Google Assistant or say Alexa, unstructured data. Uh, some of the chatbots are unstructured data. So right now, that the use cases of unstructured data is growing like exponentially, uh, and it is a very important aspects right now.
Okay.
Someone has raised a hand.
Yeah, please open up. You can unmute yourself.
Uh, Abhishek, the one thing what we can do, given I think we have crossed 7 o'clock and Abhishek session is there, I can actually you just put the question on the chat and I can answer it here only. I can.
Okay,
Is that
nice.
okay?
Yeah.
Yeah.
So,
Yeah.
so let's thanks the speaker once again of his wonderful interactive talk. So before we go into the next session, I just have some announcement. Like at the end of the next talk, we'll have a question. I mean, we'll have a test. The test will be like those who are getting more than 50% of the whole test will get a completion certificate of this workshop. There will be 10 questions. Each will be having four multiple choice, like exactly one of them will be correct. Those will be getting like six correct out of this 10 will get a completion certificate. Otherwise, if you are significantly participating this workshop with the attendance sheet that we have already provided, you have filled it up, then you will certainly get a participation certificate. And all the details how to get the certificate will be announced in our valedictory of the next session that would start from 8 o'clock. So you're all requested to join there after this session. So before going that, it's a great pleasure to welcome our next speaker, again, young and energetic with data scientist. It's Abhishek Shengupta, the same name that I am also having. And sometimes the audience may get confused that which Abhishek our previous speaker was talking about. So he was mentioning about this Abhishek, the next speaker. So Abhishek Shengupta. So Abhishek has over a decade of industry experience in end-to-end implementation of enterprise-level MN solutions across retail, customer, healthcare domain. Currently working as a principal data scientist in Walmart Global Tech India. He leads the delivery of AI, ML, and Gen AI solutions as the technical lead. Abhishek has more than 8 patents and numerous publications in various fields of ML and has secured winning positions in multiple hackathons. Abhishek obtained his postgraduate degree in statistics from Indian Statistical Institute, Kolkata, and is a gold medalist in undergraduate studies in statistics and from our own Presidency College, Kolkata. So without any further ado, it's my great pleasure to welcome Abhishek. So the screen is yours.
Thank you so much, Abhishekta, and thank you everyone for joining this session. So let me first go ahead and share my screen and just let me know if my screen is visible
Just
or
one
not.
announcement. Currently, I can see that the viewers at the YouTube channel is 80,
Mhm.
and so many of the total views may be more than 400. Maybe I'm not sure currently, but currently at live 80 are there. So please continue.
Sure. Thank you. Thanks again, Abhishekta. My screen is visible, right? I'll just take a confirmation.
Yeah, yeah.
Yes, Abhishek, it
Okay.
is.
Yeah.
Yeah.
Okay. Sure. Yeah. So what I'll do in today's session is talk about personalized experiences or personalization. Biswajit, when he was giving the example of purchasing this board game for his daughter, actually was talking about personalization, right? So I will delve deep into that and try to explain the mathematics behind all the different personalized experience that you typically see in multiple services. So I'll try to break those down. And what I've done is just divided this entire talk into three sessions. First is a general introduction about what is personalization with certain examples. Second is the underlying mathematics behind the personalization, which will be the crux of this talk. And finally, we'll talk briefly about what the future of personalization holds. And again, to keep it interactive, what we'll do is that after every session, we can pause for questions. Yeah. So, what is personalization? So, we all know what personalization or personalized experiences mean, but this slide is mainly to give a formal definition to that term of personalization. So, any tailoring of content, layout, and functionality of, say, an app and web page, a service, and so on to meet specific needs, preferences, and behaviors of users. That can be a single user or that can be a group of similar users. So any such tailoring or targeting of your content layout and functionality is something that we call as personalization. And what is the main goal of personalization? The objective is to increase your user engagement, user satisfaction, and also retention of users by making the experience more relevant, meaningful, and specially targeted or relevant to a particular customer. Now, what are the main types of personalization? Again, there can be multiple types. I've taken the top three. So the first one is what we call as content customization. So if any of you have visited these news articles on the web, so you can see that once you have viewed a certain number of articles, it always shows you articles which are related to topics that you have frequently read or views. And this is true for your feeds, your Instagram feeds, your Facebook feeds as well, right? So whatever you have scrolled previously, you get content related to that and that only. So that is your content customization or personalization. The second one is behavioral targeting, and this you typically see in your e-commerce or retail platforms, wherein an e-com site recommends products similar to those a user has already bought, or if the user has viewed but not purchased, and so on. So that's behavioral targeting. The third one is demographic personalization, which is mainly based on the user demographics, for example, the user age, the user gender, the location from which the user has logged in, and so on. So, an example is, again, in certain web pages, you are only showed age appropriate content. That's another sort of personalization. So, these are, again, the main buckets under which you can categorize your different types of personalization strategies. So let's explain these more with some examples. So the first example is a popular website that we all know, which is Pinterest. So what does Pinterest do? So when you log into or sign up to Pinterest, it asks you about what your maybe top three or top five preferences, hobbies are. You select them, you click on done, and then it creates a personalized page for you with only your relevant interests. So Pinterest typically uses this combination of this declared data, your preferences, and localization for personalization. So how it does that, we will come to later, but this is one classic example of your content-based personalization. Second one, another classic example is Netflix. So we all know that Netflix has a very well-defined recommendation engine, and it's quite popular as well and quite state of the art. So it shows you recommendations of movies and series based on your previous user preferences, based on what you've viewed previously, based on what thumbs up and thumbs down ratings you've given to previous content. And at the end, it gives you this percentage map, right? Percentage match, sorry. So for every show, you get a percentage map. Here it shows 94% match. And again, it uses data science and ML to come to this percentage so that you know that what is the percentage map to what your user preferences and what it's currently showing. So another classic example of recommendation. Third one, let me go. Yeah, so this is retail platforms, right? Any or e-com platforms that you see. So they rely heavily on personalization algorithms to provide your targeted ads, recommendations, and also offers. So sometimes you can see offers that are tailor-made for you as well. So all of these are examples of how retail platforms rely on personalization algorithms. So what are the benefits? I briefly talked about them in the first slide. Let me just go into the details of this in this slide. First is definitely improved user engagement. So the users are more likely to stay and interact with a site or a service if it feels relevant. Secondly, conversion rate. So tailor-made experiences can increase the likelihood of users making purchases if they feel connected to the service that the service provider is providing. Third is enhance customer loyalty. So building a personalized experience builds trust, and it also encourages return visits. So something in the retail world that we call as user stickiness. So how often the user is coming back to my service and not going to any competitor service, right? So that is something that I would definitely want. So again, an unique experience and a tailored experience actually ensures customer loyalty. And lastly, and perhaps the most interesting thing, is it actually results in a increased AOV or an increased average order value. So by encouraging the users to upgrade to more premium versions of the products that they're currently browsing, or recommending complementary products. So these are classic examples of upselling and cross-selling. So many of times you have seen that you're trying to say buy a camera. So my website recommends to you that, okay, you're buying a camera, why not buy a tripod as well? Why not buy a camera lens as well? So these are all cross-selling strategies to increase the overall basket value and then gain more revenue from that. So these are all the benefits that personalization gives to you. So now that we have understood the basics of personalization, I will go into the underlying mathematics of how these work. So maybe we'll just take a minute if there are any questions. Otherwise, I'll go into the mathematics part of it. I don't think there are any questions right now. So let me move on to the mathematics. Yeah. So as you understood from this entire, the prologue that I gave. So what is the underlying theme of? Sorry, it's coming as a marker. Yeah. What is the underlying theme of personalization? So the fundamental crux of personalization is something which we call as a recommendation engine. That is how to decide what to recommend to which user. So you can consider this a recommendation engine as also a filtering tool. So consider that you have this whole universe of items that you are selling, or whole universe of series that you want to show. But how about I filter and only show those relevant items or movies or shows to you based on my user preference. So consider this recommendation engine as a sophisticated data filtering tool to recommend the most relevant items to a particular customer. And how does it do that? It operates on the principle of finding patterns in your customer behavior data, and these patterns can be collected implicitly or explicitly. So this is something that we will delve into details in the subsequent slides. So there are two main classes of recommendation engines. So I will cover mainly one of them in today's session. So something that we call as collaborative filtering. So what is collaborative filtering? Collaborative filtering essentially means that you're making recommendations based on the collective or collaborative behavior of users. So take this example here. So this is Alice and this is Bob. So Alice likes these two movies, and we have identified that Alice and Bob have similar behavior. How to derive that will come to later. So we know that Alice and Bob are similar users. So Alice has viewed these two movies. So Bob, let me recommend this movie to Bob because this movie has been liked by Alice. So this is how we are mining the collective information of both Bob and Alice in order to recommend a particular movie to Bob. So Alice has seen this movie, hence I'm recommending this to Bob because Alice and Bob are same users or similar users. So this is what we call as collaborative filtering. The other type of filtering is what we call content-based filtering. So this is not on getting the information from the user behavior, but more on similarity of the items that you are giving to the user. So what we are doing here is that Bob has watched this particular movie and has liked it. And this movie has certain characteristics. For example, this might be a thriller movie, which is less than 1.5 hours of length and maybe stars Tom Cruise in it. So now I'm trying to find similar movies which has this particular characteristics, and I find another movie and I'm recommending that movie to Bob. So here there is no Alice or any other user involved. Based on what Bob has viewed earlier, I'm trying to find similar movies for Bob and then recommending it back to him. So this is what is called content-based filtering, and this in order for content-based filtering to work, we need this information attributes, right? So for example, what type of movie is it, how long is it, so on and so forth. So for today's session, we will mainly be covering collaborative filtering. Content-based filtering is something I'll just give you a brief glimpse of, and if time permits, we can go there. Perfect. Okay, let me erase this and then go on to the next slide. So again, within collaborative filtering also, there are two types of collaborative filtering. The first one is what we called memory-based filtering. The second one is what we called model-based filtering. So what is memory-based filtering? So memory-based filtering relies on the direct use of user and item interaction to compute similarities. Okay. Again, within memory based also there are two types of filtering: user and item. Let's talk about user first. Let's take this example here. Now you can see that there are two girls and a boy, and this girl actually likes or has purchased maybe grapes, strawberry, watermelon, and oranges. Okay. Now what I'm doing is that I'm trying to find other users who are similar to this particular person, or this particular girl. So what I see is that this particular boy has already purchased strawberry and watermelon. So out of the four items which the girl had purchased, this boy has purchased two of them. So this means that this girl and this boy have very similar purchase patterns. So now what I'm doing, the other two items which the girl had purchased but the boy hasn't purchased, I'm recommending these two items to the boy. Right? So this is user filtering. So I'm finding users similar to the target user, and I'm recommending the items which the target user liked. Right? So this is my target user. I found a similar user. I saw the similar user had bought all these four items, and hence I'm recommending these two items to this particular user. So this is user filtering. Next is item filtering. Again, similar concept, but I'm flipping things around. So I'm first finding items similar to what the user liked and recommending them. So let's take this example. So again, four types of fruits here. So what I see is that whenever grapes are bought, watermelons are also bought. For example, this user, whenever she bought grapes, she also bought watermelon. This user, whenever she brought grapes, she bought watermelon. So that's why this user has brought watermelon but not grapes. So I'm recommending grape to this user. So whenever grapes are brought, watermelon is bought by these two users. So for the third user, what I'm doing is that because the third user has bought watermelon, I'm also recommending grapes to the third user. So just the converse of user-based filtering is item-based filtering. So in user, I'm looking at similar users. In item, I'm looking at similar items. That's it. Okay. And the flip side of things is model-based collaborative filtering. What model-based does is that it converts this entire dynamics that we see into a user item matrix. So on the row, you see 5 different users. On the column, you see 6 different movies the users have watched. And this is the ratings that these guys have provided for each one of the movies, right? And based on that, what we are trying to do is decompose this entire matrix into a low dimensional matrix. Again, we will come deep into what model based means, but know this, that while this one requires explicit interactions between each user and each product, in model based, what we are doing is that we are trying to simplify the procedure using ML, using linear algebra, for example. So what we're doing is that we are decomposing this data into lower dimensional matrices so that my users can be defined with a lower dimensional vector space. My items can be defined into a lower dimensional vector space, and using this, I can predict new movies for a new user or these users as well. Again, we'll come to the details, but this is the main difference between memory based and model based. There is no lower dimensional reduction here. There is a lower dimensional reduction in the space here. Perfect. So let's go on to memory based first. Okay. So the first one, as I told, memory based has two, right? User and item. So let's talk about user. So user. So essentially what it is that in retail side, you see that people like you also like this. This exactly is what user collaborative filtering is. That how similar people, which products have they bought. That's it. So what will be the first step for this? You have to find people like you. So how do you find people like you? First, calculate similarity between each users. So you define the similarity between two users X and Y. And how do you define similarity? So there are so many similarity defining metrics, right? So you can have your cosine similarity. In this example, I have chosen Pearson's correlation coefficient as a measure of similarity between two users. So what I'm doing here, I'm considering all the different items. So IXY is my set of items which both user X and user Y have rated. By rated, I mean they've either give ratings to movies, purchased an item, whatever. So this is the common set of items which both user X and user Y have rated. And then I'm checking the average rating that they have given. So RXI is the rating that user X has given to item I. RYI is the rating that user Y has given to item I. And then I'm computing the similarity using a Pearson's correlation coefficient. I think you're all aware of what that is, right? And then I'm getting a similarity score between X and Y, which ranges between -1 to 1. Correct? So now I got similarity scores. Next, what do we do? So now what I have to do is that for each user hue, now that I have all the pairwise similarity scores, I find out who my nearest neighbors are. By neighbors, I mean users. So I have to find out that if I am a user U, who are my most similar users. So there will be a U1, U2, U3. These will be my most similar users. So what I do is that I use a nearest neighbor algorithm. There are many nearest neighbor algorithms that you can use so that I can group the most similar users together. So that's what this image shows. And then I've just put a note that you can use many techniques, but these are very computationally intensive. So it takes a lot of time to find these clusters of similar users. So there are techniques like local sensitive hashing, etc., which can increase the time to which can decrease the time to compute these nearest neighbors. So at the end of step 2, I have for each user, I have identified who its most nearest users are. So now what is my third step? My third step would be, once I've identified all this, I will move over and predict the final score. So what am I doing here? So for a particular user, I'm trying to predict what will be the rating for that user for an item I which they have not purchased or rated previously. So I'm trying to predict this RUI hat, which is that what will be the predicted rating that this particular user will give to this item I, which they have not rated previously. So how do I do that? Simple enough. What I do is that I take this particular user use average score, and then I try to weight this score with what my most similar users have rated this item. So I take the set of top n users who have the most similar item, who are most similar to user U and have rated the item I, and I look at their rating. So these users have rated item I. They've given them a rating, some rating between 1 to 10, right? And these are my users who are most similar to my user U. So what am I doing is that I'm just modifying the base rating of user U with this other most similar users and using a weighted average. So my similarity score is just a weight. This K is my normalizing factor. So what I'm doing is that I'm taking an average of all the ratings that these users have given for this particular item I, and using it to modify my score. That's it, what I'm doing. Now a question might come is that why is this required, right? So why do I need this? So I could have simply ended my equation here, right? So I'm taking all the ratings of all the other users, taking an average and modifying my score. Why do I require this? So the reason that we require this is it's a normalization factor. And this normalization is to account for the fact that there will be different people who provide ratings in different scales. So for two users, both of which have given rating 7, for the first user, it might mean that he's very satisfied with the product. For the 7 user, a rating 7 out of 10 might mean that he's not at all satisfied. So how do I normalize for this different thought processes and this different ratings in the scales? So that is why I'm normalizing them with a mean score as well. So this is how I arrive at my final rating for that particular user for item I. And then if this RUI predicted is high enough, I'm recommending the item I to the user U. That's exactly what I'm doing. So this was a lot of math. So I'll just take a pause, and if you guys have any questions, just let me know.
So those were in our our YouTube
I'll just
channel,
keep it.
requested to type your questions so that I can convey to the speaker. And those who are in our Google Meet can directly ask questions by unmuting themselves, or maybe you can write it down on the chat box. Okay, I think no question yet. So please continue the next session. I will
I'll
ask the question.
yeah.
Yeah.
Perfect. Yeah. So this is exactly how user-user collaborative filtering works. So the other type that I was telling you about, which is item-item collaborative filtering, which is what? So if you like this, you might like that. So if you like this item, you might like also that item, right? How does that work? It's exactly the same as your user-user collaborative filtering, but what I doing is that I'm just replacing my user or switching my user and my item definitions. So previously what I was doing, I was calculating the similarity between two users X and Y. Now I'm computing the similarity between two items X and Y. That's it. And again, previously I was taking the nearest neighbors of the users. Now I'm taking the nearest neighbors of the items. And lastly, finally, I'm computing the rating score of item U for user I. Previously, it was user U, item I. Now it's item U and user I. The I mean, when we share the slides, you can take a look at the equations. The equations remain exactly the same. It's just that I am reversing or switching the terminologies between user and item. So my X and Y's are the items, U is my item, and then my I becomes my user. That's it. So I'll not go into details into that. It's the exact same thing. Awesome. So next, now go into the other one, which is your matrix based, which is perhaps one of the most important or interesting things in this talk, which is your matrix based factorization, which is your user item matrix factorization. So why do we need this? This is mainly what I have mentioned previously as well, that your user or your item strategies are very difficult to scale, because again, you have to compare all these direct comparisons between each user, each item, compare your similarity, then find out your nearest neighbors, then predict and all that, right? So it leads to slower processing times, and it's very difficult to scale when you have tons of users, thousands, millions of users, and thousands of items. So what do we do here? We switch to user item collaborative filtering or matrix factorization. So the goal here is that first you build up this user item interaction matrix. So we took this example. So each of these users are the rows, each of these movies are the columns. So have your 5 viewers and you have 6 movies, and each user have given them a particular rating. There will be some users, so this user has not watched this movie, so it doesn't know. This user has not watched the movie, so it doesn't know. This user has not watched this movie, so it doesn't know. I mean, it doesn't have a ranking, so there will be blanks in between, obviously. So now the idea here is, how do I factorize this entire matrix into two low ranked matrices? So what I'm saying is that there is too much information here, and just computing interactions from here will take too much time. Why not I reduce the dimension into lower dimensions? So for example, I factorize this into two matrices. One is my user matrix, is what I call, and the other is what I call my item matrix. So my user matrix has the exact same number of rows as my users, but my number of columns is only 3. So I've reduced the dimensionality. My item matrix has the exact number of columns as equal to the total number of movies, but I've reduced the total number of rows. So this is also dimensionality reduction. So what I'm calling this matrix is that this is nothing but a dimensional representation or a latent representation of the user. And my item matrix is again a low dimensional or a latent representation of the items. And what I'm saying here is that, so this user representation, which is highlighted in orange, multiplied by this item representation, which is highlighted in orange, gives me this code that this user has given to this item. Similarly, for green also, for this user, my this user representation in green multiplied by my this item representation in green gives me what this user has given to this particular item, what rating he or she has given. So essentially what we're trying to do, reduce the dimension of this matrix and then calculate low dimensional representations of this big matrix. So I guess most of the folks who are here, at least on the Google Meet, are from maths, right? So what is the most common form of dimensionality reduction or matrix factorization? It's singular value decomposition, right? So what does singular value decomposition say? So any matrix, it need not be square, that can be decomposed into the product of three matrices, right? So where the first and the third matrices are orthonormal, the columns of them at least, and then the middle matrix is a square diagonal matrix with positive real entries, which are called as singular values. And I think most of us know this. So this is where the collaborative filtering gets its inspiration from, is what we do typically. So what we need, in the previous slide we showed that we need two matrices, but here we are saying we are getting three matrices. So what do we do here? Because my sigma is a diagonal matrix, I simply break this into two parts, which is sigma half and sigma half. That is, I take the square root of each of these diagonal elements, and then I create these two identical matrices, which is sigma half and sigma half, where sigma half into sigma half is your sigma. And then my user matrix and my item matrix is nothing but, my user matrix is u into sigma half, and my item matrix is my sigma half into v. That's it. So already I have broken down this interaction matrix into my user matrix and my item matrix. That's simple. But is it simple though? Because one trick here is that, as I mentioned, right, not all users will be rating all the items, because some users might not have seen that particular movie at all. So there will be blank values or missing values in this entire data set. So what do we do here? So how can we do matrix factorization when there are incomplete values in my interaction matrix? So this is my next slide, which talks about matrix factorization for your incomplete matrix. So again, let's take this problem. I'm just scaling down the problem to just 3 users and 3 movies so that we can do a step-by-step walkthrough of how this actually works. So user 1 has watched movie 1 and movie 2, gave them ratings of 3 and 4. He has not watched movie 3, so no rating. User 2 has not watched movie 1, no rating. He has given ratings for movie 2 and 3. Similarly, for user 3, he has not watched movie 2. He has given ratings for movie 1 and movie 3. So the question that we want to answer is that, what is the recommended rating of movie 1 for user 2? So what should user 2 give a rating to movie 1? As in, what should be the predicted rating of user 2 to movie 1? And again, if the rating is high enough, we will recommend movie 1 to user 2. So for that, we need to predict this blank value. How do we do that? So again, coming to matrix factorization, what we need to do is that, again, we need to find two matrices P and Q, where by finding P and Q, I mean that you need to fill in all these values. You need to know all the values of all the cells in these matrices, so that P into Q gives me this R, right? Now again, R is incomplete. So what I'm trying to do is that I'm trying to find a matrix which is P into Q gives me that particular matrix, which let me call it as an R prime. So what I'm suggesting here is that let me make R prime as close to R as possible for my non-empty values. So my R prime 1, 1 should be as close to 3 as possible. My R prime 1, 2 should be as close to 4 as possible. My R prime 2, 2 has to be as close to 5 as possible. Same for each of them. With the yellow ones, which are blank, I'm not bothered what the value is. But for the ones where I have actual values, I need to make sure that they lie as close to each other as possible, right? So how do I do that? So again, so what is the, first of all, what is my loss function here? So I want to minimize the distance between each one of these components, this, and similarly for the others. So that is what I'm exactly doing here. I'm trying to minimize my squared error loss between my R prime, which is nothing but this P into Q, and taking the difference of that from my original observed value, which is R, and trying to reduce the sum of squares differences. And then I'm adding a regularizing factor. This is something extra that I'm adding. We need not pay more attention to this. This is done to prevent overfitting so that I'm not overfitting. So this is exactly what we need, and we need to solve for this particular loss function, and we need to get estimates of all of these which can minimize this particular loss. So how do I do that? So there is this technique. I don't know if I think many of you would be aware of stochastic gradient descent. If not, you can just check this up. So stochastic gradient descent is a classic iterative example wherein we give random values, where we start with random values of these p's and q's. We start with them, put in these values, and see the distance between this r prime and r, and then gradually increase or decrease these values as needed until we have achieved the least error. So this is what we are doing at every iteration. We are modifying the values of p's and q's from the earlier value so that it minimizes the distance. So if we take an example, maybe we start with these random values, and then p into q gives me my first value is 4.21, 3.81, 6.34, and so on. And as you can see, the distance between the actual and the predicted is quite high. So in the next iteration, we increase or decrease these values to these new values, and then we see what the new values in r prime are. So now also we can see that the distance between this and this has slightly reduced. However, the distance between 3 and 5.21 has increased, so on and so forth. So we keep on increasing and decreasing these values based on that equation so that we finally arrive at the local optimum. So this, my stochastic gradient does not give me a global optimum, it gives me a local optimum, but I think for this convex optimization problem we should be good with it. So now these are my final values of your p's and q's, and then as you can see, my r prime is almost equal to r. It will never be exactly equal, so I am trying to minimize the error as much as possible. So now you see it's 3, it's 2.95, it's 4, it's 4.01, it's 5, it's 4.96, and so on. So the values are very close to each other. So then this becomes my final q, p, this becomes my final q, and then what am I doing? I am getting my final p into q, which is my final r prime. And look, now I've filled up these empty spaces which were not here as well. So I'm using this optimized p and q to find the new representation to infer my recommendations. So now, in order to answer the original question, what was my original question? That what is the recommended rating of movie 1 for user 2? We did not have an answer here, but now I have an answer here. So if I have to recommend this movie movie 1 to user 2, my recommendation is it's a 3 out of 5. So most probably I will recommend this movie to user 2. So this is exactly how matrix factorization works, and this is pure linear algebra, pure math that is used to come to this recommended rating, right? So okay, I'll just take a quick pause before I move to the final section. Any questions here? I don't think there are any questions here.
So Biswajit is actually giving the answers to all the questions on both
Perfect.
YouTube as well as in Google Meet. So
Awesome.
okay, please carry on. Yeah.
Cool. I'll continue then. Yeah. So lastly, maybe I'll not go into details. I talked about content-based recommendations as well, right?
P. Ravi Kumar, he says, can you explain this recommendation once again?
Yeah. So again, it's a very involved thing. So what I'll do is that we will again be sharing the slides again. But what I'm essentially doing is that I had this blank values here. What I'm trying to do is that I'm trying to fill up this blank values, as simple as that. What am I trying to do here? I'm trying to find low level user and item representations so that the multiplication of this gives me my final matrix. In order to arrive here, I'm using error loss minimization technique known as stochastic gradient descent, so that I get values which are very close to the actual values. And now that I've obtained my final values or my final predictions of P and Q, I'm multiplying them to get my final recommendation. Again, what we will do is that when we share the slides, you can take the look at each step-by-step working and then understand this in much more details. Perfect. Yeah. So my last topic would be factorization machines, which is a generalization of your matrix factorization. in the sense that previously, remember, we talked about, right? So how do I incorporate additional user details? So the examples that I showed here does not take into consideration what the user's age is, what the user's gender is, what my item dimensions are, or anything like that. It does not take into account. So in order to do that, what we do is that we generalize matrix factorization into factorization machines. So again, I'll not go into the details of this, but what I'm doing here is that I'm flattening this entire matrix form of a data into something like a row dimension. So all my user matrices are these. So these are my users, U1, U2, U3. My items are in the same row, which is my item 1, item 2, item 3. And also I'm adding some additional features. So I'm adding, maybe this is my user age. I'm just taking an example. Maybe this is the duration of the movie or something like that. So I'm taking all these auxiliary features into account. And then my final Y is what is the observed rating that this particular user one gave to this particular item. So I'm flattening things out and then posing this into some sort of a regression problem instead of this matrix factorization problem. Again, how to solve this, we'll go into that, not go into that. But what we're doing is that flattening things out, I'm incorporating my users, my items, as well as these additional features. And then I am framing this in the form of a quadratic linear regression. I'm also taking factor-wise interactions, so interactions between x1 and x2, x2 and x3, x1 and x3, and so forth. And then I'm just minimizing the squared error loss. Again, I mean, you can look up factorization machines. So there are a lot of techniques used to further optimize this. But the idea here is that if you want to incorporate your auxiliary features as well, this is exactly factorization machines is the way to go. All right. So I'll come to the end of my presentation with one slide about the future. So what does the future of personalization hold? So generative AI, again, Viswajit also talked a lot about this. So generative AI has a very high potential for recommendation engine. So I can use Gen AI to create unique recommendations, create unique content, which can be tailored towards the customer needs. Real-time personalization. So this is sort of an upcoming trend that's coming up, so that it enables us to recommend or change our recommendations real time. So consider, for example, say a Spotify playlist. So based on whether a user has skipped a particular music track or fast forwarded a particular music track, my recommendations can change automatically. So that is something, personalization or recommendation, that is happening real time, right? So that's another sort of realm shifting work that's occurring in the realm of personalization. Thirdly is predictive recommendation. So even before I know that I have to make a particular purchase, AI recommends that for me. So some flavor of it you have seen in your normal shopping apps, right? So it says that, are you out of sugar? Or it looks like you're out of sugar, so kindly order that. So sometimes I don't even remember that whether I am out of sugar or not, but the app remembers, right? So a lot of AI can go here and then make predictive recommendations even before a user searches for a particular item. And lastly, AR. So augmented reality is also a hot topic nowadays. So already you have things like your virtual try-on for your spectacles, for your t-shirts, and so on, wherein you don't even have to visit the store. And future work also involves virtual trying on of different furniture. So how does a bed look like in your room? How does a sofa look like in your room? How does a wall in your room painted blue looks like? All these things can be possible through the AR part of, so the AR advances that are currently being made. You just need to take a picture, not even a 3D picture. You can just take a 2D picture from your phone. The app in its background will convert it into 3D, and then it will incorporate that particular object into your house and show you how it looks like. So these are all the different exciting future things that personalization holds for us. Yeah, so that brings me to the end of my talk, and I would open up to questions, and thank you.
Okay, so any question or comments, please open up. Those who are in Google Meet and those who are in YouTube can type your question. So many of the answers are already been given by Vishwajit. Okay, so I cannot see. I think, yeah. Yeah, so he is actually giving the answers directly in both.
Yes, Abhishek. Abhishek, I'm putting it both.
Yeah. So basically, as far as I understand, the things are quite advanced, your stage. So, like, what could be the stage? Like, it's a step by step things. If you just recap once again,
Mhm.
because many of the guys may join late, so they may come up with the ideas that what exactly. So, most of the viewers here are mostly from either stat background or maths background. So they want to know exactly what should be the step to become a data scientist.
Biswajit, you want to take this up?
Yeah. So, Abhishek, as I mentioned, right, I think, and someone, Rigam also mentioned, asked this question that what are the skill set we need if you want to do well in hackathon, right? And Abhishek is a prime example. I think he have won multiple hackathons. Very recently, I think he was invited in a Google office because he won a hackathon from Walmart. So I think one of the core skill set, Abhishek, as I mentioned, right, that first of all is coding, because at the end of the day you have to code, right? It's not a theoretical thing, so you have to code. Second is having a mathematics and statistics foundation is critical, because other than that you will not be able to understand the machine learning algorithm fully. And the third component is machine learning for sure. So if you have to do well in hackathon and even in the interviews, these are the things you need to definitely know. And the fourth thing I want to add is basically practice, because it's you have to practice, right? Means, and the example which I gave was Kaggle. So you have to keep enroll yourself to the practice assignments, enroll yourself in some hackathons, right? And some hackathons actually are practice hackathons as well, which goes for 3 months, 4 months. And then keep solving the problems, right? Because until unless you do it hands on, uh, you will never be able to reach at a certain stage. So I think four things: coding, mathematics, statistics, machine learning, and practice.
Right. Sir, what is the key difference between data scientist and software engineers?
Yeah. So, Shuruji, the answer is basically that software engineer doesn't deal with anything related to data, right? Say, for example, uh, let me give you an example. It's like you have creating one system, right? It's not a data system. Say, for example, what iPhone or any software, right? Any example of software, Abhishek, you can give it. Say MATLAB.
Yeah, say MATLAB, right?
MATLAB, yeah, MATLAB is a software, right? SAS is a software. So someone who is actually building this kind of a software, right? They don't need any data. They have certain features that, okay, I need this module, and you need to go and create this module. So essentially, the subjectivity, the two streams are totally different. Means there are overlap, but the difference in that sense that you are solving a particular business problem using mathematics and statistics. That's the foundation of data science. And there is a very subjective element to it. Means compared to a software is basically is very objective. You know that, okay, these are the things you needed in the software, these are the features you need, right? However, though there are features needed, but in the data science there is a iterative approach, because maybe first time you reach a 50% accuracy, right? And your objective is maybe to build something which is 80% accurate. So you have to keep again, it's not about just running the algorithm. You have to go back, create new features, run again, then see maybe it has moved from 50 to 60, you do again. So you have to there are a lot of iterative elements compared to a software engineering. Where software engineering play a major role in data science is basically when you are scaling the solution, right? That is where we use a lot of software engineering practices. Shruti, did I answer your question? Yeah, Sabyasachi. So I think again, just go to Kaggle. You will get a there is a very well-known project called Titanic. what is that prediction of how many people died in Tanzania?
Yeah.
Yeah. So I think that's like a first project which I think a lot of people do. So you can actually, Sabyasachi, you can go to the Kaggle and do that particular Titanic project. It's very famous.
Okay, so great. So again, many people are asking about the PPTs. So as I mentioned, we'll discuss how to share with all of you, maybe in the next session or maybe in the this valedictory session, we'll discuss about it. So one just basic question is like when you get a raw data,
Yeah.
so how do you think that which model should be what are the intuitions behind that, how to start with, or what would be your goal, how to set with being at a very high level of your so you start with the data, or others start with the data, then they pre-process and then
Yeah.
come to you. So what are the actual system that when something like say Walmart or say even Amazon, they think of a project and they have the data, then how to start with?
Yeah. So I can take this question, Rishi.
Yeah. Yeah. Go ahead. Go ahead.
Yeah, no. So I mean, speaking of Walmart, I think again, this is true not for Walmart, for anywhere, right? So again, so there is this data and there is this problem, right? So you have the data and then there is a typical business problem that you're trying to solve. So what we typically do is that first of all, looking at the data, we try to understand that whether this data fits. I mean, there is enough to solve the problem, right? So what can be a problem? It can be a supervised problem. It can be classification, where you're trying to classify something into ones and zeros. It can be prediction. You're trying to predict future sales, so on and so forth, right? So formulating the problem actually divides your total model space into two, right? You have separate models for supervised data, you have different models for unsupervised data, for classification you have something, for prediction you have something, for regression you have certain models, right? So based on the problem statement, we have divided this entire class of problems into these small class of models, right? And now within that, so what you typically try to do is that first of all, you see that whether the data is arranged in the particular structure required for these models to work, and then you arrange the data. There is a lot of EDA involved as well. So first of all, understanding whether the data is enough, what sort of additional data are required, and then whether the data is structured in that format that is required for the model. And then for some models, again, what we typically try to do is that we try to do, there's something that we call a model registry. So if we try on different models and see that which model works the best for this, and then there are different metrics for goodness of fit, right? So whichever model gives you the most goodness of fit during a training, during an inference, we try and choose that particular model. So again, it's a trial and error method of seeing that. So we have some initial intuition that these models might work, but unless we have tried that model on the data set, we won't know that whether it will work perfectly or not. So that's a combination of intuition, trial and error, what is the state of the art, looking at all of those, fine-tuning that model for the data set that's given to us. All of this involved towards driving towards that final model, which gives you the best result for inference.
Okay, so another question is, so do you have a data first and then problem, or the problem comes first and then depending upon the problem you collect data? Or
For us, it's typically problem first, but generally you have certain data which are always there, right? So for example, for Walmart being a retail company, you'll always have sales data, you'll always have inventory data. That's the basic data that we have, right? But again, some problems might demand additional data which we did not have previously. For that, we need to collect the data from our data foundations and then get the data and then use those additional data to solve that problem. And also there might be cases where additional data can also improve the accuracy. So whatever data we have is enough, but there can be additional data which can improve our accuracy in that. So when that is there, we can also incorporate those data elements to further improve our model as well.
okay, so another question is, sir, how important is domain experience in data science field? Suppose in working to implement data scientist in healthcare, do I need good amount of knowledge of the disease, etc.?
Not really. Okay, go ahead, Vincent.
Yeah, I think it depends on the problem. So definitely some amount of understanding is needed, right? Say, for example, there are certain disease which are very critical versus compared to some say skin disease or something like that, which may not be critical, right? So, and you are building a model. So for example, a critical disease, say I'm doing a prediction, just imagine the amount of accuracy we need. Definitely even a 0.1% is a fatal. So that is the precision that we are looking for. versus maybe some disease which where we can have some room. Maybe obviously any disease should not be like that. If everything should be 100% correct, but at least there should be some room, right? So essentially, understanding. I'm not saying you need to be expert, but having some understanding of that particular domain for which you are solving the problem, or that area under the healthcare, is definitely important. Otherwise, it will be a plain and simple data, and then you are fitting the model without understanding the context.
Okay, great. So I don't see any further questions. So if you have any further question, you can catch it up by sending me email or even to Bishwajit or Abhishek.
Yeah.
Yeah, so that would be great. And we're really thankful to both the speakers for their such an interactive talk. So, and it's, I think, really helpful for the students who joined here and many others who are dreaming about to be a data scientist. Thank you very much for this workshop. And I hope that this is a very fruitful one, this workshop. And this is one of our tries. And we'll continue it with more and more workshops on this particular topic. So thank you once again. And yeah.
Thank you, everyone.
Thank
Have a
you.
good day.
Fun.
Thank you.
So
Bye-bye.
now we are just one announcement before we start with our next session. We are just having for 10 minutes. Mind that the test will be for 10 minutes. So those will be having more than 50% of the score will certainly get a certificate that you have successfully completed the workshop. Otherwise, those who are just viewing this, having less than 50% of the score will get participation certificate if you filled up the forms correctly and regularly for both the sessions. Okay, so now I'm going to share with you this link. Mind that the link will be valid only for 10 minutes. So it would be a 10-minute exam, because otherwise you may use other links to get your answers. So yeah, I'll just share with you. So have you received it? Just on this here. Can you see this link? Yeah, in between, we will switch to our next technical session. And I think Carl is already there. Carl?
Yes, I'm here.
Great. And you have all the documents that I sent yesterday?
Yes, I
Okay.
have those.
Yeah, great. So now it's our next technical session. It's the technical session 5. Sorry, 5. It's not 5, it's 6, technical session 6. And in this technical session, we had actually 3 of the talks, but due to some unavoidable reason, Professor Arnab Sengupta will not be able to join us, but he has sent his slides. So if anybody is interested, just send me email. I'll be glad to share the slides. So we'll have 2 talks here, one by Professor PG Romeo and another by Professor Konad Bashu. So I think Konad will be joining us soon. So without any further ado, it's my great pleasure to hand it over to the chairperson, Carl Su from US. Carl, the screen is yours.
Hey, thank you. The first speaker, again, is Professor P.G. Romero. Professor Romero is currently serving the Department of Mathematics at the Cochin University of Science and Technology. He completed his MS in Mathematics from the University of Kerala in India in 1985. He went on to pursue his PhD at the same institution where he earned his doctorate in 1993. His doctoral research focused on the topic of cross connections of concordant semigroups, and he completed his thesis under the guidance of his advisor, Professor KSS Namburapet. And Professor Romero is coming to us from Cochin University of Science and Technology. And Professor, you can proceed at your pleasure.
Hello? Hello? Hello?
Yeah, we can hear you, and we can
Am I audible?
yeah, you are audible, and we can view your slides as well.
Okay. Thank you. Thank you. Very good evening to all of you. And at the outset, let me thank the organizers, especially Professor Abhishek Adhikari, for inviting me for this talk. And also respected chairman. Shall I start? Hello?
Yeah, please.
Okay.
Yeah.
So today I'm going to say something about cross connections of normal categories. So basically, category theory is my area of research, and this is an invitation to all of you to the wonderful world of category theory. And this is actually more or less a tool for doing mathematics. And in this talk, I am dealing with a category which we call a normal category. And this category is a very special type of category in which the speciality, I mean, it has sub-object relation, factorization of morphisms, and sufficiently many cones. And why we are interested in this category is, in his wonderful paper on cross connections, Professor Namboodiripad described they used these categories to study the structure of semigroups. And the idea here is using the ideals. That ideal, I mean, just like semigroup ideal, that is something very similar to ring ideal. Using the principal ideals of the semigroup, that means principal means both left and right. But these principal ideals has the structure of a normal category. That is why we begin with a normal category. And the idea of this talk is, if you start with this type of category, normal category, or their duals also. And we have two categories. I say they are two, two categories. Hello. Okay. In this talk, the main points I am going to discuss is we are considering two categories, C and D, say normal categories. That means I'm being a very specialized type of categories in which we have sub-object relation, factorization of morphisms, and cones. And a very familiar example is the category of sets and subsets. Here, if you take the category as sets and its subsets, and the morphisms are maps between sets, or that familiar category has all these properties. And if you have two normal categories and their duals, which I call n star C and n star C and D are normal categories, and n star C and n star C are their normal duals, then certain functors between one category and the dual of the other. So a pair of functors. These quadruple is basically called a cross connection, and this cross connection determines okay. This cross connection determines using this cross connection we can construct the semigroup. That means we start with the ideals of a semigroup as categories and consider the duals of those categories. This quadruple, using this quadruple, that means two categories C, D, and their newer duals N star C, N star D, and the connection between these categories and their duals. This quadruple, using this quadruple, we can construct the semigroup. That means the idea is you get a representation. You start with an abstract semigroup. You get a representation using this cross connection. And later on, this is extended to several other structures. And in a wild sense, what I'm going to tell you is that if you start with appropriately proper fine categories and their duals and this type of cross connections, you can recapture the structure. That type of representation, you get a representation of the structure. That type of representation is termed as the cross connection representation. I illustrate these for the semigroups and some examples. That is the whole idea of this talk. So the invitation to this wonderful world of category theory and the abstract is starting with appropriate categories and their duals arising from some structure, or the categories with appropriate structure and their duals and these cross connections, you can get a representation of the structure. That is the main theme of the talk. And here, I recall some basic concepts in semigroups and the ideal categories of semigroups, and I illustrate the cross connection. That is my idea. Okay, semigroup has a very fundamental mathematical structure. Perhaps I believe that everybody know what is a semigroup. A non-empty set together with the associative binary operation. And a very special type of semigroup is a regular semigroup, and that is an element is called a regular. If there exists an element X is called a regular. If there exists a Y such that X, Y, X equal to X, that's some obviously in the familiar group you have it is already a semigroup. In the case of groups, you know, for every element there is an inverse. But even if there is not such an inverse, if this type of regular elements exist, this is called a generalized inverse, and set together with an associative binary operation, and this type of inverses is called a regular semigroup. And in semigroup, an element is called a idempotent if x square equal to x, as we already know, in a group there is only one idempotent, but semi-group there are very possible to have too many idempotents. In fact, there are semi-groups in which every element is an idempotent is also possible. And we denote the idempotents in the semi-group by E of S, and these are special type of elements. And some another thing I want to invite your attention is some certain relations on semi-group. They are called Green's relations. There are certain equivalence relations, and these idempotent elements and Green's relations, these are very special in the case of semi-groups, and they play a very good role in the study of semi-groups. And these ideals generated by these ideals, uh, left ideals are L classes are left ideals, right ideals, and two-sided ideals, and J classes, etc. are there. And these principal ideals generated by, and one thing we have to notice in a regular semi-group, it is sufficient to consider principal ideal generated by idempotent elements, because every other principal ideal or in any class of principal ideals, there is an element there is an idempotent which is in this class. So it is sufficient to consider idempotent elements and principal ideals generated by idempotents. So if you take the principal ideal generated by left ideal generated by idempotent is what that one category, right ideal generated by the principal ideal, right principal ideals are another category. So from this, in this way, you get two categories. And these categories, these principal ideas LS and RS, they are duals. You can construct their duals. They are certain set valued functors, functor categories. They are duals, and these LS, RS, they are normal duals. N star LS, N star RS, and a local isomorphism between these constitute the cross connection of a cross connection semi-group. SCD and gamma S. Gamma S means RS2 N star L of S is gamma S. Similarly, the another thing, LS2 N star R of S will be the dual connection. One is called the connection, and another is called the dual connection, and together this is a cross connection. And in the case of vector space also, I give the example, V is a vector space, and you know the all singular linear transformations on a vector space forms a semi-group. And that semi-group case also we can illustrate the left ideal, right ideals, and cross connection semi-group of that. That is the example I am providing here. So in this talk, I go through the slightly go to the details. First one is, as I already mentioned, semi-group, regular semi-groups, and ideals. Semi-group is a non-empty set together with an associative binary operation. A regular semi-group means every element is regular. That means for every x, there is a y such x, y, x equal to x. And ideal means left ideals and right ideals. S is a semi-group. SE, left ideal generated by an idempotent SC. Those are similarly right ideals. These are categories. And now I go for the basic definition of categories. So category is a wonderful concept. This is basically consists of two sets, the vertex set and called objects, and each class of objects A and B, CAB is the morphism from each pair AB. You have the morphism from A to B, and you have a composition of morphisms. Whenever the codomain of the one will be the domain of the other, and that means AB and BC, then it can be composed. It is not necessary that every morphism will be composable, but once this condition is satisfied, that is the codomain of the first one agrees with the domain, then it is composable, and whenever composable, it is associative, and you have another. So this is associativity, and for each A, F from A to B and G from C to you have identity morphism. Each vertex, you have F is a morphism from A to B. There is a morphism. That means every object can be identified as the identity morphism. And in fact, the category itself can be considered as morphisms alone. That's also possible. Okay, that is, this is the identity object, and these are the basic, very general concept of categories. And examples are sets, the category of sets, objects are sets, and morphisms are functors. Group, the category of groups, the objects are groups, and the morphisms are group homomorphism. In fact, you can consider a single group as a category in which the only one object, that is a group itself, and the elements of the group can be considered as arrows. And in that way also you can view a category. And another thing is functor. Functor, C and D are two categories. A functor from C to D is this thing. You have a morphism. C to D is a functor. If you have these properties, and one example of a functor is the power set functor. Usual power set, and each arrow assigns to maps from Px to Py. Another important concept is natural transformation between two functors. If F and G are functors between two categories, a natural transformation is defined like this. You have natural transformation eta from F to G is a family of mappings such that each is this commutative diagram. This diagram commutes, and you can see that if you consider the functors in a category as objects and the natural transformation between functors as morphisms, that itself forms a category, and that is usually termed as the functor category. ST etc. are functors from C to D. A category whose objects are functors between categories and morphisms are natural transformations of such functors. With the composition of morphisms, the composition of natural transformation is a category, and this category is termed as the functor category. And as I mentioned, for the normal categories, C and D, as I mentioned, the ideal categories of semigroup, their normal duals are certain functor categories that I will show you. Anyway, another thing I want to define is a pre-order. A pre-order is a category in which the form set PP, the morphisms from P to P dash contains at most one morphism, and such a category is termed as a pre-order. And this is another important concept for us, the category with sub-objects. A category, small category P is a subcategory, P is a strict pre-order with the B of vertex set of P is same as vertex set of C, and for every F below, F is a monomorphism, and this condition, such a property is there, such categories are called categories with sub-objects. And as I mentioned, this set category, group category, vector space category, modules category, etc. are all categories with sub-objects. The sub-object relation induces from the usual inclusion relation. And another important property of the normal category I mentioned is factorization of morphisms. Okay. A morphism in a category C, this sub-object is said to have factorization if F can be expressed as Pm, where P is an epimorphism and M is an embody. And a normal factorization is a factorization of the form QUJ, where Q is a retraction, U is an isomorphism, and J is an inclusion. Such a factorization is generally termed as normal factorization. And another concept, depending heavily on normal categories, is the concept of a cone. C be a category with sub-objects, and D is an object, a mapping from vertex set of C, that means object set of C to the morphisms of C. is called a cone with the base BC to the vertex D. If gamma C, that means from each vertex you have a component to the designated vertex called the D, the vertex of the cone. And if this type of inclusion relation among these type of inclusion relations are there, then such a concept is generally called a cone. And a normal category is a category with sub-objects, which any morphism has a normal factorization, and each vertex there is a normal cone. This has the special properties of a normal category. A category is sub-object relation, and any morphism has normal factorization, and of course every inclusion splits, and at each vertex there is a cone with the vertex C. Such a category is called a normal category, and this normal category you have a designated set called M set of a cone, that is the components which are isomorphisms. And this is another important thing we have to observe. The set of normal cones in a normal category with this composition of cones, gamma 1 and gamma 2 are two cones with the vertex, for example, some C1 or C2, something like that, etc. If you have gamma 1, composition gamma 2 is gamma 1 star the epimorphic component of the other. With this cone composition, the set of all cones in a normal category forms a regular semigroup. So we have, if you start with a normal category, you have cones, and that cones forms a semigroup, regular semigroup. That is the speciality of normal categories. Any category in which you can have this property and the cones forms a regular semigroup is a normal category. Now I define H functors. In these cones, you can define a functor using these cones, and that functors together with the natural transformation between such functors forms a category. That category is generally termed as normal category, normal dual category, normal dual, N star C. If C is the category, N star C is the dual category. Normal dual category is the category whose objects are these H functors, and the morphisms are natural transformation between such functors. This forms a functor category, and that is the normal dual. And this normal categories and this given a normal category C and D, their duals, normal duals is N star C and N star D, and these four categories you can have morphisms from this type of morphisms. That construction is I just mentioned here. You have C and D, some sort of normal categories. Define an object function from C is a normal category. Define G from RTC. TC, the semigroup of cones. You take the right ideal category of this semigroup, then it is able to find a morphism from C to the right ideal category semigroup of the semigroup TC. You have find a G, and similarly you have find a C and D are isomorphism of normal categories. You get a functor from N star C to N star D, and generally finally but you get C and D are normal categories. You can have two functors, one gamma from D to N star C and delta from C to N star D. That means C and D are normal categories, a functor from one category to the normal dual of the other, and another functor from the second category to the normal dual of the first one. Such a mappings, gamma and delta, are local isomorphisms, and these local isomorphisms, gamma, delta, together with C, D, forms the quadruple, which we call the cross connection. And using that cross connection, we can construct a semi group which matches, which is a regular semi group. We can prove. That is the idea of this. And for that, if say you have CD, gamma, and delta, you have the cross connection, then you can find a cross connection semi group. For that, you really need some bifunctors and natural bijection between bifunctors. Even if this gamma and delta are localized functors from C to n star D and D to n star C, given a functor, you can define a bifunctor. This functor induces bifunctors and natural bijection between bifunctors and a cross connection. If once the this in the case of if C and D are ideal categories of a same semi group, then this delta can be replaced by the dual of gamma, and in that case you can have the cross connection CD gamma, and the other delta will be replaced by gamma star, and you get the cross connection as CD gamma. And in that case, C and D are normal categories. Gamma from D to n star C is the connection. You can have some designated sets which are idempotents, E gamma, and that means this E gamma you can have cones with gamma CD. CD for each CD belongs to E gamma. Gamma CD denotes a unique cone such a way that gamma from D to n star C is defined by gamma of D is equal to H gamma CD. This H gamma CD is a cone, and H gamma CD is the functor determined by the cone, and that is the definition of gamma from D to n star C. And every cone in gamma CD expressed as this form. And finally, what we get is C and D are normal categories. CD gamma is a cross connection. And for each CD belongs to CD, there is a natural bijection from gamma CD to gamma star CD. And we get, using this natural bijection, our aim is to get a pair of cones, gamma, gamma star. This pair of cones, together with this binary composition, gamma, gamma star, delta, delta star is equal to gamma delta, gamma star, delta star. This is a semi-group, and this semi-group is usually called the cross-connection semi-group. And this cross-connection semi-group is actually isomorphic to the semi-group, to a semi-group whose ideals are this LS and RS, principal ideals. That means if you start with two normal categories C and D, and their duals n star C and n star D, if these functors gamma and delta, these functors, using these functors, you can define a bifunctor. You can construct a pair of cones. This pair of cones is called a linked pair of cones, and this linked pair of cones with this binary operation forms a semi-group, and this semi-group is the cross connection semi-group, which we call the cross connection representation of a regular semi-group. That is the idea. And an example, in the example I mentioned, we have the cross connection representation of a regular semi-group. To take a regular semi-group as, then the category LS is the category of left ideals. Objects are left ideals. SE, E belongs to E of S, and morphisms are this type of translation. Rho, EUF, where EUF is a right translation. That means EUF means a translation from SC to SF. So any element in SC, you translate right by some X going to XU, something that U. This U is taken from the ideal ESF, the set ESF. If you take a U in ESF and you take an element in SC, multiply right by U, translate by right translation, then it is a mapping from SC to SF. And similarly, for the right ideal category RS, we can have a left translation, partial left translation. And these categories, RS and LS, are normal categories. And you can see that morphism gamma is from RS to N star LS, and gamma star is from LS to N star RS, are local isomorphisms. And these local isomorphisms are connected by this bijection, chi S from gamma S to gamma star S. Those components are this one. This is bijective, and this using this gamma S and gamma star S, you get a pair of cones. Pair of cones, rho e lambda f, and that pair of cones together with this type of composition. This type of composition forms a semigroup, and that semigroup is the cross connection semigroup of the regular semigroup S. And that is the major idea. Another example is cross connection semigroup of singular endomorphs. This is an illustration. See, as we already know, you have a vector space. If you take the singular endomorphisms on the vector space, it is a multiplicative semigroup. Okay. You take non-singular bijections, that forms a group, but here we take the singular endomorphisms of the vector space, and those forms a multiplicative semigroup. And this semigroup, the category of principal left ideals of this singular endomorphism semigroup, it can be characterized by the subspace category of SV. SV is the ideal categories. V is a vector space, singular endomorphism forms a semigroup, and the category of principal left ideals of singular endomorphism. This is a semigroup. Its principal left ideals is characterized by the subspace category of SV. V is a vector space, subspace is category of SV, and the category SV is this category SV. Subspace category is a normal category, and its set of normal cones under the binary operation of cones is a regular semigroup, and we denote this semigroup of T of SV, and the semigroup of all normal cones in this category of principal left ideals is isomorphic to SV. That is the one step of the cross connection, and a normal dual of this category is the annihilator category, AV, which is isomorphic to category S of B star. S of B star is the dual vector space. So you on any vector space, you have the dual space, and subspaces of the dual space, proper subspace of B star can be identified with the normal dual of S of B, and you have these things, the normal dual N star of S of B of the subspace category isomorphic to AB. Dually, N star of AB is isomorphic to SV, and the semigroup semigroup of cones T of AB of normal cones in isomorphic to singular endomorphisms of the semigroup of singular endomorphisms. It's opposite, and if V is a finite dimensional vector space over K, N star S of V is isomorphic to the normal category SV.
Professor,
Yes.
you have about another 5 minutes.
Okay. I will be winding. And in that case, a gamma from SB to SB star and gamma star from this SB annihilated category, this is a space category. This will constitute a cross connection semigroup, and every cross connection semigroup arising from between this AB and SV is isomorphic to SV, and that is the thing. So the here my aim is to invite your attention to this cross connection theory. I'm just giving the hints. Anybody who are interested can look into this paper, second one, number report, theory of cross connections, and this one, cross connections of linear transformation semigroup, semigroup forum paper in 2018, and the mere abstract of this talk is if you start with specialized kind of categories, which we call normal category, they are nothing but some categories with sub-object relation, factorization of morphisms, and codes. There are several situation we can have categories with that property, just like the category of sets, category of vector spaces, etc. These categories have these properties, and similar there are very many categories having these properties. And if you take these type of categories, normal categories, you can construct their normal duals. So if you take a pair of categories, normal categories, and their pair of duals, so you get 4 categories, and you can have some local isomorphism from one category to the dual of the other. So you get 2 local isomorphism, and in particular, if this ideal category, this C and D have some relation, just like the case of semi-group, one is left ideal category, another is right ideal category. Is that sort of duality? Some duality like that is there, then you can have the cross connections. This gamma and delta are not independent. Delta can be replaced by the dual of gamma. In that case, you have CD gamma will give you a cross connection, and using a cross connection, you can construct a cross connection semi-group, which will turns out to be the representation of the structure. This can be imitated to any algebraic structure or Sinus structure. You can have categories, appropriate categories, and you take the cross connections of those categories and you build up a structure. That structure will be a representation, and that representation is called a cross connection representation. This is my my idea is to invite your attention to these type of representations, and these type of representations very much there in very other situation. Very well known dualities in mathematics are somewhat similar to this type of duality, just like this homology, cohomology duality, and like let's say several dualities in mathematics have some similarity with this. This is also a duality, which we call the cross connection duality. It can be analogous with these very well known dualities of mathematics. And I stop with this. And if any questions, I can try to answer.
Okay, are there any questions?
Okay. Yeah. So if you have any question, then please write it down on the chat box. I cannot see any question yet. Okay, so if you have any further question, you can just send me email so that I can convey this message to Professor Romeo, and we'll get back to you. Yeah, I think now we can thank Professor Romeo.
Thank you.
And if the next speaker will be Professor Kanad Basu. Professor Kanad Basu is a highly accomplished data leader with over 20 years of experience in academia and industry, holding a PhD in applied and computational mathematics. He serves as a professor of practice at the Marshall School of Business Management at the University of Southern California. Beyond academia, he is co-founder of an AI startup and serves as an advisor to several others. Dr. Basu's extensive expertise spans statistical modeling, strategic vision, and data-driven decision-making as evidenced by Miller's peer-reviewed publications and significant industry contributions. Notably in his role as head of data science at Delia, he demonstrated the exceptional leadership in data strategy, artificial intelligence, and machine learning. As a passionate educator and frequent speaker at international conferences, Dr. Basu is committed to mentoring the next generation of data leaders. His work emphasizes the transformative power of innovative data science applications, driving impactful change across industries. Professor Kanad Basu comes to us from the University of Southern California, and the title of his paper is AI's True Dangers, What We've Overlooked in the Hype. Professor, you may proceed.
Thank you. Thank you for the very kind introduction. Thank you, Professor Odhikari, for this invite. And I would like to thank also my brother Vishwajit for a different reason, because it's very early in the morning. I'm not a early riser, and he makes sure that I'm here. Uh, uh, let's start my presentation. And can you see that my screen?
Yes.
Yeah, it's visible.
Okay.
There you go.
And the movement is visible, right?
Yeah.
Okay, great. So this is something we should be very careful about when we are embracing new technology. That what are the other thing we need to be careful about, uh, don't get me wrong, I'm extremely happy and grateful to have this new technology changing our lifestyle, our workflow, everything. But also I am worried that, like anything, like if these technologies are not well understood and well maintained, how it will be affecting the overall health of our mother nature. There are something needs to be addressed right here and right now. Mainly, I'll be talking about the environmental effect, ethics of applying generative AI. That is the really, really transformative technology right now. And I believe that this will change the entire human civilization in a good manner. But we need to be little bit cautious about something related to this technology. So, so we all know what is artificial intelligence. It generally refers to the use of computer system designed to mimic human cognitive functions such as understanding and producing language. So there are a lot of different example of artificial intelligence, as you know, and use and interact every day. I can say the chatbot, personalized recommendation. Like you can see that AI powered Netflix and Spotify to suggest movies and songs based on your preferences. Smart assistant, like virtual assistants like Siri, Alexa, use AI to understand and respond to your voice. Healthcare diagnostics, AI can help doctor detect diseases like cancer through advanced imaging analysis. And the example is like countless. Like this is really cool examples that this technology is changing the way we work, and it's a change the change the way things we interact with. uh, AI can lead to issues also as biases, privacy violation, job loss. But again, I should rectify. Job loss in some category is eminent. Everything, like when I was growing up, there is a job called telephone operator. That job doesn't exist anymore. That I am not referring to. I'm thinking about unnecessary job loss that are not needed, just not for the sake of using technology. Ethical dilemmas and increased inequalities. So here in the whole presentation, what is my aim? I just want to focus some of the area, and I will give you some link to further study. My 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 intention is no way to point out like these are bad, this is bad. I am telling you again and again, I'm extremely grateful and excited about these new technologies, but something I need to point out for you for the study and your information. And AI can lead to issues such as bias. That's I already mentioned, unnecessary replacement, those kind of thing. AI is becoming a part of our daily life. You understand that every day we use something that is like that is powered by AI, that is using the algorithms of AI, from recommendation to what to binge, what to decide who gets a loan. Like when you apply to the bank to get a loan to buy a car or buy a home, like who will be the most reliable person to give the loan. Those are also run by a lot of AI recommendation system. Like if we are not careful about using the technology in the right manner, AI can be biased just like a gossip column. That's I really think. Now I will run three quizzes here, poll, I would say poll, with Professor Odhikari. And I invite all of the audience to answer to the best of your knowledge. It's not an exam in any manner, and just to see that what is your idea about this kind of question. So first question that I need to ask is, when did the earliest discussion of AI ethics begin? There are four options: 1930, for 50, 70s, and 1990s. So, Professor Odhikari, can you share the link with the audience and so that they can complete the polling?
Yeah, I'm sharing, but all the three questions are simultaneously they will get.
Okay. Okay. They should take time. Just give them 1 minute and let me know. And
So maybe you can just show the three questions simultaneously so that.
okay. So this is the first question about the ethics discussion, and there is another question. Let me see. Environment impact. Second question is, how much water is estimated to be consumed by each interaction with ChatGPT? For each of the like the question you asked to the ChatGPT, 100 ml, 250 ml, 500 ml, and 1.5 liter. And the last question I have, that is also environmental impact, that's saying how much of US electricity supply are data centers projected to use by 2030s. Again, I'm not expecting you guys know the answer. Just give a base possible answer to your knowledge or maybe your hunt. So,
That's-
Professor Odhikari, when it is done, let me know.
Yeah, so no question yet. I mean, nothing has submitted. Nobody has submitted yet. So maybe just 1 minute, we will stop it.
Sure. And it is anonymous, so you don't have to worry about like who answer what. So just feel free to do the best you can do.
Link is not working. Let me check. Okay, let's see. Okay. Yeah, it's working. Could you please check once again? It's working. Yeah, people are submitting. Yeah, till now, five responses we have already received. 6, 7.
This is not very important. Like just I will explain this anyway. So whenever you feel comfortable, Professor Odhikari, just let me know. I'll begin.
Yeah, please continue. The students who are going to submit it. Yeah,
Okay.
I will
So,
come. Maybe they will take some time. I'll just give it.
sure.
Yeah.
Sure. Then we'll discuss later. This is not very important. I thought it would be a like involving activity, but it's okay. So AI ethics, that how we you can use the technology so that like you all benefited without any violation of any privacy law, any ethical issues, the ethical dilemmas, inequality, those kind of things. That's called the ethics, right? That is the by definition like what is right, what is wrong. So actually AI is not a new thing, as you most of you know. There have been research. Scientists have been researching on AI for a long time. Just it boomed in early 2010. The real word AI. Before that, it used to be like analytics. That was not an AI per se, but when the computer was like accessible more, computer power storage were more accessible, more affordable, that boom came around that time. And scientists were had this tool to use the computer power and computer memory to do more, run this algorithm, because it can be computationally very expensive. So that time, but it is not a new thing. Like this is scientists are doing research for years. Um, so you'll be surprised that the earliest discussion of AI ethics date back to 1950s. 1950s, they first started like, thinking about that what is wrong, what is right, uh, if it is making fair decision to the greater society, such and such. This period is marked as the beginning of serious consideration of implication of creating intelligent machine. As I'm sure you have heard about scientist Alan Turing, his work, particularly in his 1950s paper, Computational Machineries and Intelligence. This is a huge paper, Computing Machineries and Intelligence, which introduced the Turing test. You all know this is the Turing test is one of the like most celebrated scientific tests there introduced in this paper, is one of the seminal moment of history of AI ethics. In that paper, Alan Turing like introduced the AI ethics term first. Turing's work raised fundamental question about machine intelligence, responsibility, and the potential consequence of creating machine that could mimic the human cognitive functions. So basically, this is mimicking the how human work, how human think, how human act, right? So in this paper, first time they bought the idea like, okay, what about the machine intelligence and responsibility and potential consequence if we use this kind of algorithm? So 1950s, this is the like little bit of the history of AI ethics. 1950s is the early discussion, as I mentioned, that origins of AI ethics track back to the discussion around the potential consequence of intelligent machine, notably with Alan Turing's work and Turing test, raising question about machine intelligence and responsibility. Then there are some winter that like not a lot of the work was being published. People are still doing research, but again in 1990s, accountability and safety was raised, in different article and discussion. The who is accountable if they make any wrong decision or the decision which might be controversial. With AI system becoming more prevalent, discussion shifted to the issues of accountability, safety, and the importance of transparency in AI decision making. Then we come to 2000. AI in society was introduced. Like what is the bigger society-wise effect of this technology become integral to the society? The focus on ethical issues intensified during that time, with the debate around privacy, surveillance, and digital divide gaining prominence. Uh, then we come to 2010. We first started like using ethical AI framework, like how to address this problem. All the data laws was like trying to build up around that time. So data ethical AI framework was introduced, and this decade saw the development of formal ethical framework and guidelines by the government, organization, and the companies to address concern about bias, transparency, and the ethical use of AI. Then 2020s, we all know, we have seen this revolution. AI ethics and regulation was introduced in the form of like data laws. In United States, they have CCPA. In Europe, you have GDPR, and India, they have a law, something. They just introduced the law last year. So all the government has started like regulation around the AI algorithm. The conversation around AI ethics has expanding into policy and regulation, with a growing emphasis on creating laws to ensure AI development and use responsibly, addressing global concerns like AI role in surveillance, discrimination, and human rights. Is very important, right? So still things are moving because this is a very new field. The discussions are always changing. So nothing is developed, concrete, because AI algorithms are changing every day, if I say so, or so frequently. When the algorithms are changing, constants will be changing, and the laws will be formatting differently, right? The good news, what is the good news? AI can help solve some of the toughest problem we are facing, from medical technology to healthcare, um, financial sector, maybe environmental, global warming, those kind of things. That is a very good news, because it has the power. It has the power to solve some of the problem first if it is applied properly. The bad news is, if it is built without care, it can amplify biases and injustice, and no one wants that, right? So AI bias occurs when I'm defining what is AI bias, right? This is the definition of AI bias. AI bias occurs when algorithms produce unfair or discriminatory outcomes due to a biased data or flawed design. So again, AI bias is, we call it is a bias. You know the regular definition of bias, but the AI bias is the situation when the AI algorithm produce unfair and discriminatory outcomes due to the biased data that we use to train the model and flawed design of the algorithm. You know, so the world around us are full of biases. You know that. You know, so when you imagine a face of scientist, what will you imagine? Anyone can say? So if I say a face of scientist, what will come to your mind? Anyone here want to volunteer? Okay, so I have my own bias. I'm not going to that area. Everyone has their own bias. Like our bias are formed by the environment we grow up, the data around us, like form our bias. You know, uh, uh, it can be totally like without knowing we form our mental bias, but nonetheless we all have our own biases, right? So I have some picture of a scientist when I think about scientists, but I asked this question to ChatGPT. You know, I ran this with ChatGPT image generator algorithm, and I got this picture. This is created by ChatGPT 4.0. You know, so you can see all male, all in serious looks, white male, especially very serious people with like aprons, lab coats, that makes sense. But I don't see a lot of women here. And this is the direct picture image created by ChatGPT in a 3-4 months back. I'm not sure whether they have improved or fixed the algorithm by now, but it was created around September this year. So you can see all men, white male, very serious with aprons and with lab coats. No woman, I can see. That's a bias. Women can be scientists. No brown skin or black skin people. So these are biased because whenever you are imagining scientists, you are getting this kind of responses, by this algorithm. This is the three images were created by ChatGPT 4.0. First one I asked like a CEO, image of a CEO. I didn't mention male. I didn't mention white. This is what the image they created. Second one is the like lawyer. I didn't mention white lawyer. I didn't mention male lawyer. This is the image they created. And the last one, a senator, which is like a MP in India, like the highest politician. We here we call senator in US. So I asked like senator in image of a senator. Again, they came up with a white male image. But I see in these three profession, CEO, lawyer, and senator, there are a lot of women representation there. Lot of African American population are represented there. There are some Asian representation there. So definitely this is producing bias. Am I clear about it? Do you see my point? Correct? Yes, no, yes, no, what? Professor Odhikari? You
Yeah.
see the okay,
Yes, it's
right.
great. Yeah.
Let's move on, okay? So let's take a quick tour of some AI face plans, and these are real world example. What the example I'm giving you is a real world example, and spoiler alert: it's not pretty, but we can learn from this example. Okay, so sometimes the AI went wrong. So this is the this is the one of the study happened. It is in Detroit, Michigan, 2019, and there's a face recognition. There is a guy who are like in the school. He has a confrontation or with a teacher, and the police actually captured delivery boy. You can see the article. Delivery boy who has nothing to do with this incident, and delivery like meal delivery guy like Uber, or in India I would say uh, Zomato or Swiggy, those kind of profession, in the traffic light, thinking this is that guy, and as a result, this gentleman lost his like job, because Oliver, his name was Michael Oliver, when he was arrested during a traffic stop and accused of grabbing a phone from the teacher who was recording a fight outside the school, then breaking it. So basically, the facial recognition, they thought two, African American black young gentlemen, their face, they didn't recognize in the more prominent manner. As a result, the other gentleman has to face the consequence of losing his job, because he was arrested wrongfully by using the AI face recognition technology. uh, the risks of generative AI, like what does the future hold if we don't understand the risks that comes with it, or the algorithm. The risks are we think might happen later. We need to think about how bad things could be in the future. It's up to us to understand what risks come with using new technologies and what those risks could be. This is a very important statement, because we think like, well, now, say for example, the festive season is going on, and maybe I have 100 rupees, in my hand, uh, and I spend everything on the festive season without thinking what will happen in the future. That is not very sustainable and intelligent. I'm just giving you a metaphor. So basically, we need to think all the way through. Okay. So some use cases, right? Real use cases. So uh, this is a very interesting use case. Our New Zealand supermarket, they launch a AI powered meal planning app with leftover, that designed to help customer to use leftover creatively. Generated a bizarre and dangerous two recipes, including the chlorine gas, poison bread sandwiches. It is a real thing, poison bread sandwiches, and mosquito repellent roast potato, drawing attention for his unusual, potentially harm suggestions. They actually ask like, you can make a sandwich with bread sandwich with fluorine gas, and you can see that it came to the the newspaper article, and the grocery store was called Park and Save in New Zealand. And the big question here is that, okay, I understand they made a mistake. The big question, if I am not very careful what is my recommendation is going, but the big question is, who is to blame if someone accidentally bites the sandwich and dies? Is it the person who made the sandwich following the recipe, the developer who builds the app using the tech, or the scientist who created the LML model that underpin the app? You need to think about it. Like if somebody accidentally like bite the sandwich and as a result get some health hazard, who is responsible? You know. So also the mosquito repellent roast potato. Like this is bizarre. Like how come like our mosquito repellent roast potato that the app AI power app will be suggesting? You know, we are not very careful while designing the app. So second question is the Gemini, the Google version of ChatGPT. They created this like this. They tried to be inclusive about creating every race into the something. When they create things, they have this plan, and Gemini said historical image generation actually mistakenly uh, made some images of Chinese Nazi or black Nazi, and they later apologized for that because there is no Chinese Nazi or black Nazi was there, but this was the real thing they generated. The concern arose with ChatGPT launch about potential misuse by student. Now we're talking about the generative AI in education. Claiming AI generated work as their own. So I can assign a student some work. They can use the generative AI to get the answer and submit, and that is called a cheating. But this sparked the fear about the impact of education and integrity of academic judgment. AI-powered risk detection tools introduced to monitor and detect non-original work generated by ChatGPT or similar technologies. There are a lot of tools out there. These detection tools are often unreliable, inaccurate, and sometimes flagging original student work as AI generated. You know, Buyers find in this tool with a Stanford University study, revealing that they proportionately flag work by non-native English speaker due to text perplexity. So this is the problem, because the training data involve most of the work by the native English speaker. So whenever they have a work submitted by non-native English speaker, they flag it as a non-original work. Also, it affected the creative professional. Generative AI transformed the creative work by providing powerful tools, enhances brainstorming, design, and storytelling process, but raising concern about authorship and ownership of AI generated content. Uh, there are a lot of debates going on over the impact of job security in the creative industry. Like, let it be like script writing, designing, all kind of thing in the movie industry, theater industry, creative writing industry. Uh, there are definitely, it comes with some highlights that need to clear regulation of an ethical guidelines. So real quick, in 2023, visual artist Sarah Anderson, Kelly McCarran, and Carla Ortiz filed a class action suit against the several artificial intelligence company, alleging them the companies, like those companies where AI model violated the copyright law by using the artist's work in their own training dataset without getting their permission. Okay.
You have about 5 minutes, Professor.
Okay. I'll be done by then. Also, explosive labor practices. Generative AI is designed with guidelines and filtered to prevent offensive and harmful content. Offensive and harmful content include, sexual content, nudity, slang, those kind of things. So they need to remove that from the training data. But the problem was that it relies on large data set and content moderation technique to maintain ethical standard. So you have to like physically, manually identify those like offensive content, harmful content from the training data. The effectiveness of this system depends on the quality of training data and safeguards, right? Filtering and evaluating the training data can be grueling tasks and traumatizing tasks for the worker. And it was came to our attention by Time magazine. They reported the Kenyan worker, like they are age 16, 17, they are paid less than $2 an hour to handle this extreme content, and as a result the harsh impact on their mind and society. Can you imagine 16 and 17 years old, they're paid less than $2 just to manually detect the sexual content, nudity, violence, offensive language. This is horrible practice, that happened with ChatGPT training data set. So I'm not going to the poll. I'm almost done. Environmental impact. First environmental impact quiz was like how much water is estimated to be consumed by each introduction. It is 500 milliliter. Each introduction with ChatGPT is estimated to consume about 500 ml of water, because you have to cool down the data center. This estimate comes from the energy intensive process required to cool data center where the AI models are hosted. However, exact amount depends on various factors like efficiency of data center and the specific energy source used.
Konat, just one information that out of 11, 5 of the viewers, they have correctly given the answer, 500 milliliters.
Very good.
Okay.
Very good. So you see that the huge environmental impact creating the and running the LLM model is significant, but often not transparent, right? Training ChatGPT, I'm not talking about the latest model. ChatGPT has carbon emission comparable to driving a car from the Earth to the moon and back. The car, that much of carbon emission happened during the training of ChatGPT. Large amount of water are used to cool the server during the training process of this model. As you know, like it used like 500 ml of water with 16 million daily users. 16 million daily users. That from August 2024. This amount is a substantial daily water usage for Chat GPT alone. Think about other models Claude, Gemini. Think about how much water is being used. And third poll is how much USA electric supplies are data center projected to use energy by 2023. This is by the EPRI. And this answer I'm telling you, it is between 4.6 to 9.1 by 2030. That's a huge amount of energy. And it will create some inequality because the powerful corporate tech companies, they have the money, they will pay for whatever it takes, like even the increased price of electricity. And as a result, the more poorer nation, poorer section of the society, they will not be able to afford electricity if we are not careful right now. So, yes, thank you for the listening. Please, if you have any question. Yeah.
Any questions?
Those who are in YouTube, kindly ask the question, write the questions in the chat box so that I can share it directly to Konrad. And those who are in Google Meet can directly open up. They can unmute themselves or write the questions on the chat box. Okay, one thing is that many of the participants, they want your slides. So is it possible?
I'll send
Okay, okay.
later.
So,
I think Abhishek, I already shared that with you.
okay, yeah, but I need your permission to share them.
Oh yeah, yes, yes. Knowledge is free.
Okay.
Knowledge is free. Uh,
Thank you, sir.
okay, great. I can talk like 24 hours about this because this is my latest like increase interest about sustainable, responsible AI thing. So this is a very important topic that people are thinking about.
Okay. So any question more? People on YouTube can write it down there.
Okay.
Okay. So if more questions would be there, then kindly write it there. Okay. How one can correct the wrong decision by AI?
Uh, Now, they're very good question, but what is like this is a first stage of problem. What is wrong? What is right? Correct. So without knowing that what you are referring is very difficult for me to address because it's so new. Who asked this question? Can I interact with him or her?
Uh, no, she is in on YouTube channel, so she cannot speak. But
Okay.
I will share the link of Google Meet link. So maybe those who are interested may directly come into here and then ask the question directly.
So once we have defined what is wrong, what is right, because this is very relative, right? In our different cultural standard, right wrong definition as a different society, the right wrong definition is different. So once we agreed upon what is right, what is wrong, given that is fixed, then I think it is a iteration process. If you think that algorithm making like constant wrong decision according to the standard, then you have to go back to see if it is a flaw of the algorithm or the data you are training with. You know, so I think I know my well respected friend Bishwajit work on generative AI a lot, and he knows like all the time you have to look at the finding the problem with the data set is easier. Finding the problem with algorithm is difficult. So then you have to change the algorithm. It's not very, the answer should not be one liner, but find if there is a problem, bias, unbalance, equality, those kind of problem with the data set, that is easier to find out. But if the problem in intrinsic to the algorithm itself, it's very difficult, very difficult to find out, but possible. Difficult and possible, impossible is a two different linguistic term. I'm saying it's difficult. I'm not saying it's not impossible. It's not impossible. Is that answer my question?
Okay. Orchonak, whether you have joined here? Okay. Another question is when we use sometimes ChatGPT at the end, it says everything that I have given may not be correct, but also everyone addicted to it in every field.
Yes. So I think that's called hallucination. Biased. Sometimes it gives some question which are answer which are not right or maybe full of confusing elements, but it does the job. Like we as a human we also make mistake, but if ChatGPT make mistake 1 out of 100 or 2 out of 100, we need to careful, like that is called the human in the loop. You always have to put your intellect and your reasoning capacity to understand what ChatGPT is delivering you, and if that is uh, the making sense or not, right? That is called the element of human in the loop. It's very important component um, of including your own judgment before you accept what ChatGPT is saying. But I think most of the part it does a very excellent job. I personally believe no machine, no algorithm is better than human. Why the ChatGPT algorithm excels is the scaling thing. What human can do, same work uh, in 1 hour, the algorithm can do the same work in fraction of second. That's where actually the intelligent the celebration, all kind of things are happening. So yes, it can give you wrong answer, but you need to be careful. But most of the time it does a very good job. They're not intelligent, but they're very good at memorizing thing and tell you fact from historical data.
Okay, so maybe a simple question, like when we use for grammatical purposes for correcting the grammatical error or something, suppose I write a sentence being wrong grammar and it corrects it. So can anyone claims that that is done by himself or herself, or it would be like any intellectual issues regarding that?
Well, if my grammar is being corrected by someone else, I should not be claiming that is my sentence ethically, right? But
Yes, but
I see this as a help, so that's fine. It's not like you are making a writing an article by ChatGPT and publish in your own name. That is a different sector. But using for a help, we all take help every day, so I think it's fine. Help and plagiarism is a two different thing, right? Getting help,
yeah.
that is two different thing. If I'm getting help to correct my grammar or spelling, I think that is not a big deal. Like, people take help all the time.
Okay. Any other question on the YouTube? So in the context of the last question, like regarding this algorithm and data, so Amandeep says that, so basically the role of algorithm is crucial at this stage. Not
Both role of the algorithm and data quality. What do you say, Vishwajit? I know
Uh,
you are very intensively with this algorithm and data.
Yeah, no, Kanada, I think you are spot on. And before, means in my session, I mentioned that word or a phrase which is very widely used in AI industry is called garbage in and garbage out, right? So if your data is a garbage, whatever you build on top of it doesn't matter because you will get a garbage at the end, right? So I think to answer Amandi's question, it's both the data and algorithm. And Abhishek, just to add one point to your question, or even I think Sangame's question, I think most of the thing what we need to use, right, or how to use generative AI and even AI, some of this outcome is as a AI assistant. Means like Chat GPT is not a solution to everything. It's sort of an assistant to what we are essentially doing. So it helps us to do certain job, help us in doing certain job in a faster way. That's the way at least I will use it, rather than blindly trust it, even being an AI professional myself.
okay. And suppose, as Konath mentioned about, so the image that are being generated by
Yeah.
AI. So suppose I use the same word, same image, asking for the same image, whether this ChatGPT or any other AI tools or models will generate the same image every time, or they will change?
it depends on the prompt, Abhishek. So for example, if you are using the same instruction, then definitely at the back end it is going to generate almost a similar, not exactly same, because every time you run, right, you will give a different output. But I think the genre of output will be very different. However, if you want to have a separate, different thing, you need to actually modify your prompt.
Okay.
So
And
you have to add inclusivity, those kind of thing. I think modern patchwork and modern version, latest version has included a lot of the inclusivity and representing different classes. This was I think 4 months is a long time back in terms of AI revolution time.
okay. Okay. Any further question? I cannot see here.
I have something that I'm not sure how to actually say it, but in what you're doing and writing programs and chat GPT, how do you take in consideration cultural issues? That if you're trying to communicate with people worldwide and you have maybe different values or whatever, is there a way that you can check or verify what you're saying isn't offensive or isn't I don't know, out of bounds for what you're trying to communicate?
Yeah, this is a very, very uh, pertinent question, very important question in today's era. I think not one solution fits all this kind of situation. What is when you modify the data set about what is offensive, what is non-acceptable, it's more like a cultural validation, not like universal validation, correct? So what is offensive to me may not be offensive to you, right? And vice versa, correct? So I think now we have a one big umbrella to play with, and there are maybe some output that is offensive to certain culture and certain societal sector, right? But
Right.
eventually I believe this will go away with that with some mindful practices, because it will be more like local model rather than global model. Something can be global, something has to be local, right?
Yeah,
Yes.
Carl, just to add to
Go ahead,
Kanada's
yes.
point, yeah, I think this right now is being done in two levels. One level is basically, as Kanada mentioned, right, as a global level, that there are certain things which are globally not accepted, right? You are abusing someone in a certain way that is not accepted globally. So that is already being taken care by the standard chat GPT. However, the one which you mentioned, right, there are certain things which are very local, like say for maybe local to an UK or local to India or local to say China, right? So for that, you need to imbibe that into the model. So you need to create it outside, because obviously the global model will not be knowing it. So you need to create certain repository or file, and then you need to train the model saying that, hey, you know what, if you are actually doing it, running it for UK, then these are the words which are basically are not acceptable, right? So you need to tell that particular thing to the model, which happens locally. So there are certain architectures which are actually imbibe the local data, or basically data which you are fitting from outside on top of the the standard GPT model. There are certain architecture, and that's the way right now this bias thing is being taken care of.
Yes, exactly. Thank you, Vishnu.
One more question, maybe. Suppose I think there must be some work on that. Say whether it's possible to check whether it's a AI model generated text from. Suppose I generate one text from one model and give it to another model and ask the same question whether this is generated, or even himself. Suppose I generated a text in using ChatGPT and asked ChatGPT whether it's generated through ChatGPT or not. What would be the answer then?
I can answer your question, because I'll tell you a very last week incident. So we were actually submitting one paper in one of the conference, and there was a check that how much it is being written by ChatGPT. So essentially, I think there are tool which has come that if you upload the PDF file, they are going to score you based on AI generated content. So if it is on the higher side, then I don't know how exactly the the conference conference people are going to judge accordingly. But there are tools who are saying, okay, how much is this particular text or this particular content is written from ChatGPT. So I think if you see, just to answer your questions, Abhishek, in a certain way, it's that if you go to the ChatGPT, right, they uses a quite, there's certain words they use quite a lot. Like it's a very you typically don't use on a day-to-day basis, but you will see that like delve is an example. Delve is a very popular, right? So
Yeah.
so there are certain words, if you see in the phrases, you typically get to understand that it's a ChatGPT taken or maybe modified, essentially.
Yeah, I use ChatGPT regularly, and I know you can tell, like, if I know how Biswajit talks, how Abhishek that talks, because I have interaction. So a person who use ChatGPT in every day, from writing email, I don't write email and copy paste. I modify that. I get the skeleton and then modify in my own style. If you are using it for quite sometimes, there are certain construction, certain word that is typically to ChatGPT. Delvin, uh, there are a lot of similar words that are used very frequently. Every email is started, I hope this mail will find you well. This kind of thing is very atypical for ChatGPT, and you can get a sense. So if you are human can get a sense, of course a machine can get a sense. But one of the way, I'm teaching you cheating. One of the way can do, you write down something on the ChatGPT and then instruct it to modify with the Claude, then instruct it to modify it with the Gemini, and that way it will be more difficult to debunk. But still, like, intelligent machine can find it out eventually.
No, they are making it like a percentage how much it's made in, but
Yeah.
few words they can, but whether how
And this is a pattern. The pattern is not very. As a human, I can even like find out the pattern who uses and deal with this kind of wordings
Yeah.
very frequently.
But there are hacks. There are definitely hacks, Abhishek. There are hacks for sure. Yeah.
But I never recommend anybody to copy and paste ChatGPT's output. Like, that is what Vishwajit said is the exact way to define. It's your personal assistant. That's it. You have to eventually use your own judgment and reasoning and your own old flavor, if I say so. It's just a very personalized, very efficient assistant for you.
Okay, so that's really a very good interaction with all of us. So I cannot see any further question. So if not, then thanks once again. Maybe Carl, could you please?
Carl, you're on mute.
Carl, can you unmute yourself?
I'm sorry.
Yeah. Okay.
Thank you for excellent presentation and interaction there. And that was the last speaker, so I'll let you have it, Dr. Abhishek.
Okay, thank you. So it's my great pleasure to give thanks to both the speakers, Professor Romeo and Professor Konad Bashu, and of course, our very favorite session chair, Carl Soap, for this session. So that's the end of this technical session. Now we directly move forward to the next, our valedictory session. And I can see that at the end, we have 87 or 86 many participants are present over here. And also we had 61 participants in our YouTube channel. Still, it's quite late in India. It's now 9:40 p.m. So we would have a very short valedictory session. So before going to the valedictory session, let me have some announcement. now we are going to declare the score of the exam that we have taken. Also regarding the certificates and the proceedings of IMBIC is already published, and it's on the first day. From the first day, it's uploaded on the web page of IMBIC. If you just go to the web page of IMBIC, you will certainly find the previous proceedings. And in the previous proceeding section, it would be on the right side of the website. And if you click on that tab, you will directly go to, and you will see that all the previous proceedings along with the proceedings of 2024 are available there. And regarding this presentation certificate, so as usual, our conference, we miss very less number of participants who are due to some unavoidable reasons. They miss it. This year we have only 5 out of 114 participants or 114 talks. So all the talks would be uploaded on the website. The link would be given, but it would be private, not given to all. So I will share the link with all the participants who have given their presentation, and the folder would be there, and you have to just download the certificate, and the name of the certificate would be based on the paper title. So paper ID, for example, 19F or 17F, something like that. Depending upon your paper ID, you will get all the details about that. I will share with you. And regarding the test, the students, they really did quite well. So I will just now make it public so that release score, I think, send emails to this score. I'm sure that those who have given the exams, they already received the email. If not, then kindly let me know. So the scores have been given. So those who have obtained score more than or greater than equal to 12, they are going to have the certificates. But please, the certificate, making the certificate will take some time. So we have prepared the certificates for the participants, but the certificates for the who have successfully completed the workshop of data science would be sent over email. So you will receive it over email. It will take some time because it's an automated method, and through one email, I cannot send many in one day. So we'll have to send day by day. So you will certainly get, I'm sure that you all get your, so could you please write on the chat box whether you have received the score or not? So if not, then let me know. Yeah, so I get already this some answer. So it's already there. So the score is already given. So someone says that 12 marks. So those who have obtained 12 or more, they will certainly get the certificate, but please bear with us. It will take some time to send. If not, within say 15 days, please let me know. I'll just take some more days from you. 15 days, within 15 days, you will certainly get that. Regarding participation certificate, those who have filled the form significantly, that means if we see that you have been there throughout and we have given the opportunities to fill the forms many times, and if we find that you are there, again, the certificate for participation will also be sent to you, and that will also be sent automatically on your email. Again, I'm saying that it will take a lot of time because I can see that altogether there are 752 participants who have already registered for us. And then we have to check manually whether you have done it significantly, attended through this attendance. And then please share the marks once again, sir. I'm not sure. I have already, it would be sent once. So please check your email. If you have properly given your email ID, then certainly it will go to you. Or please check your spam. Hopefully it won't go to your spam, but if it might go to your spam. Okay, and the feedback form I will again going to share with you, but that's the announcement. And now it's the time for the participant. I will share with you the feedback form soon. now is the time for like how you enjoyed these things. So I have already given the link to you to join directly to the meeting. So still we can accommodate 12 more participants. So those who are in YouTube, if you want, you can get into the meeting and you can share your experience, how you experienced it. So just raise your hand through this button in the meeting. So one by one we will call, so that it won't be a chaos. So yeah, so anybody would like to say something, how you had this meeting, or how can we make this meeting more attractive or for the betterment? If you have any suggestions, you can write it down on the YouTube, or you can join directly through the meeting link that I have already shared with you in the YouTube one. Okay. So anyone would you like to say something, can unmute yourself and say whatever you would like, how you feel that the conference was, is it helpful, or what the way that we can do it in a much better way. So that we'll have a note. We'll try our best to incorporate your suggestions. It's always not that everything that we can do, but whatever we can do, we will try our best to incorporate. So please open up one by one, maybe. It's open to all. Anybody can unmute.
I just like to say that I like the format of this year's conference, and that you had workshops, and I believe that subjects were dealt with a little bit more in depth because of the additional time that the speakers had, and that I appreciated the graphics, because sometimes I couldn't follow the math because that's not my area of study, and the graphics helped me stay with the speaker. But this was a good conference. I really enjoyed being part of it.
Okay. Thank you, Carl. Anybody else? Please open up. Yeah. Mr. Das, please.
It was a great experience actually organizing such a big event in virtual mode. I was not expecting that much success actually because I also conduct many virtual events and very few people joined. But here I have seen the enthusiasm about the participant, about yourself and your team. Everything was very nice, and the management also I think is almost smooth and flawless, and we enjoyed every session, and I could not attend whole sessions, but few sessions I have attended. It was very good. And one suggestion actually, this what next means we should have some follow up of this outcome actually. I think that will help greatly to each other to excel and develop our objective. Thank you.
Yeah. So every year we review ourselves. So we give a lot of attention to the suggestions, or to the even to the whatever like bad comments, good comments, suggestions. We welcome everything, and nothing is perfect in the world. So every year we try our best to make it as good as possible. So we are making it for last 18 years consecutively, and we usually make it in offline mode, and that's also we make it in a bigger way. But this year it was a great success because of all the viewers, all the technologies that we had. Of course, my team, my all scholars, students, they helped us a lot, and it really a great hard work for all of us to make it a success. But yeah, we never think that it's a success, because the best thing is yet to come. So I'm sure that next year we will also come with some new things, new idea. Okay, thank you, Professor Das.
Another suggestion is there. There should be some coordinators whom we can contact by phone when we face some problem. Otherwise, actually, we become helpless sometime.
No, what we did it on the other hand, we did it from our side, like those who missed their talks or due to some reason they are unable to join, we make them call, because we had the phone numbers of each of the participants. We take the participants' input, and there we call it. Email, usually we try to reply back email, because you can understand within this time it's too many emails that coming. May not be, I won't be able to, or my team won't be able to give all the replies back very promptly, but we tried our best. Yeah, it's a good idea, but yeah, one of my students was giving me a suggestion that why not having a WhatsApp group. So with all the participants, we should have a WhatsApp group, so that if someone gets some problem, then it could be distributed over others, and everybody will come to know and try to help them. So yeah, it's a good
Yeah,
suggestion.
I was actually suggesting that, because what next? It means if we have a group and we can exchange our thoughts and whatever we have learned, we can think, and somebody has some question in mind, they can raise there, and we can have a good team.
Yeah, that's fine. But you being one of the organizers, sometimes it's difficulties for the organizers to manage all the
Yeah,
questions.
sometimes it becomes chaotic. I understand.
Yeah. So
Thank you. Thank you.
okay. So anybody else, please open up. Yeah, anybody, would you like to? So I get a lot of messages from the YouTube viewers. Thank you, all of them, because it's only for you only, and we worked quite hard. The whole team worked quite hard. My students, all my students, they really worked hard. So you might be seeing only me in front of you, but it's the background. A lot of people are working very hard to make it a success. So okay, so anybody would like to say something? Please open up. Any suggestions, anything that you feel bad, something that you can say? No, this year we haven't made any WhatsApp group, but next year we may think of. Yeah, so you can speak. You just come up, and whatever you like, you can share with us using your mic.
Good afternoon, sir. I'm Meenakshi Ghosh.
Yeah, hello.
Yes, sir. This was my first time with MVIC. I did my presentation and I liked all the sessions, but just that the technical sessions were good, but the presentation sessions that were going on parallelly had very few participants, like only 10 or 12, like that. So I thought that it would be better if somehow that could be combined, or more participants should listen to the paper presentations also. Then it would be better, no? That's what I thought that time.
Yeah, that's a good suggestion, but you can understand that if we're going to have 114 presentation, not parallel, then it will take around 7 days to complete it properly. So
Yes.
we were helpless actually. Otherwise, we don't actually prefer, when we make it in a offline mode, we don't prefer parallel session, because we think that every session is important and everyone should listen to others. But this time we had many students presentation. Their presentation were really good, but their material may not be that good. But this year we actually promoted the students. So we got a lot of papers or abstract coming from the students, and we gave a kind of platform to them to promote them, to make them more and more enthusiastic. regarding that. So that was one of our goals. That's why we we had to make a parallel session. But if you do not make it a parallel session, then you can see that the invited talk and the workshop, we could not make it, then it could be a 7 days long workshop. And that
So
would be,
there was a time like the invited talks were also going and these paper presentations were also going. Like which one to join? That kind of thing. Obviously, we face.
yeah, that's why this YouTube is there. That's why if you can skip one of them, because it would be in a YouTube.
We can
But
follow it later.
yeah, you can follow it later. That's why we make it. But yeah, we personally, I don't also like to have parallel sessions, but we were helpless.
Yes, but since it is online, it was better that because all the participants can join from anywhere, so that helped.
Yeah, yeah.
That gave us a good interaction. That helped.
And
But
it's really difficult for the NGO like us who had this without much funding. That you understand nowadays, it's really difficult to organize a offline conference because funding is a issue now. But still, we have one of the greatest statistician, Professor Badi Arnold, is with us. Like students, like the PhD students from Stanford or other places, they are giving their presentation. So it's really unbelievable that in a conference we could have the presentation of that standard. So it's really good. So we have a now very good connection, so we can make we can bring many big people here, because that's also convenient for them, well, because they don't have to move here and there. 1 hour or 30 minutes is fine. We could also join the industry people like Konad. All of them, they are from Presidency University, so it's easier for me to contact over them, and they are very kind to accept my invitation. So now we're trying to build it should not be only academia, it should also be industry. So it should be a combination of both industry and academia. So that's our
in both the fields,
yeah.
academic interaction with industry helps a lot.
Yeah.
Thank you, sir. And it was very great to be a part of MBIC and this presentation sessions.
It's a pleasure. Okay, hope to see you in
Hello,
future.
sir. Can I say something?
Yes, please.
Actually, sir, I could not fill up the feedback form every day due to some unavoidable reasons. I was the participant of session 4B. How can I get the participation certificate? Can you please?
So is it like you presented your paper or you just participated?
Yes, sir. I have presented.
If you have presented, then you will certainly get your presentation certificate. So if it's presented, so all my students, they have marked it. And I just now mentioned, I will share with you a link where the certificate will be available at the name of your paper ID. So you have to just download it based on your paper ID.
Okay. Thank you, sir.
Yeah.
Thank you.
Yeah, the proceedings is one question I can see. The proceedings is already available at the okay, I'll just show you. Maybe I can share my link. I will show you this proceedings. Can you see my screen?
Yes.
If you just type MAST 2024, the IMBIC conference web page will come. And there you will find that previous e-proceedings. If you click there, you will see all the previous proceedings are available. So this is our proceedings, this year proceedings. And this is available, so you can see the preface and the content. And all that. So it's this year, this is 327 pages long. So you find all the details over there. Yeah. So you can scroll by yourself. And the program is also available. So if you just go to the program, previous year program. Here you will find this previous year proceedings and technical programs. So it's also available. So this is available at the first day of the conference. So that's our usual goal, that we don't publish later on. So on the first day of every year, we publish the conference proceedings and all. Yeah. Okay. Anybody else would like to say something? Okay, so many of the feedback link talking about, I'm just again sharing with you the feedback link. But if anybody would like to say something, please continue.
Good evening, sir.
Yeah, good evening.
Sir, even I register in last minute. Your response is very ultimate, sir. Is impressive. Thanks a lot for this response for the research scholars, and it is very motivated for us, sir. Thank you so much.
Yeah, my research scholars, they actually work very hard to make it possible. So
Yes, sir.
since everything we make, like composition of things, making everything are being made by ourselves, so we don't have to rely upon any third party. So we can wait till the end, but sometimes we have to stop somewhere because we have to publish it on the first day of the conference.
Yes, sir. So it's very impressive, sir, that we are very glad to share our paper and our proceedings in this prestigious conference, sir. Thank you so much.
Yeah, it's our pleasure. Okay, anybody else? If not, then we will wind up. Sarvaj, would you like to say something?
If you kindly show us again where the online e-proceeding is available for this
Just click on the Google MSAST 2024.
Okay.
Then the web page of IMBIC will come.
Yeah.
And then on the right, you will see that previous e-proceedings.
Okay.
And if you click on that, you will get all the link about all the things.
Okay. Thanks.
Okay. Any question or comments? Professor Srivastav, are you here? Okay. Dr. Chinmoy Ghosh, would you say something? Yeah, please.
Good evening, sir.
Good evening.
Actually, sir, I'm very pleased to attend this workshop and the conference organized by IMBIC, and this is the first time I attended this. So I first thank all the organizers and the speakers, the reputed speakers. So they have delivered their lectures very nicely. What I want to say is that data science is a hot topic, and as I feel that mathematics students are the best options for this, but they are not getting job only doing mathematics recently what we are facing. So I would request IMBIC to take any other type of initiatives if they can think to promote such type of data science and machine learning course among the mathematics people in West Bengal or India, so that students can get job actually.
That's really a problem, but it could be a starting up thing, because IMBIC is just a NGO, so we have a lot of good people all over the world who are connected with us.
Yes.
Personally, I am a faculty at Presidency University, and similarly, likewise, many other students as well as faculties are involved with us. So I can say that we have started an initiative in Presidency to have a with maths, because whatever data science prerequisites are required
Yes.
are being taught in maths, but not the way the data scientists want.
Exactly.
That's the problem. So firstly, we have to understand how data scientists, or what are the things that data scientists require.
Exactly.
That's what we started understanding the things first, and then we'll try to go through or try to send the knowledge to the students.
Exactly, sir. I am also faculty of Kazi Nazrul University. So I feel the students are suffering after their MSc. That's why I am proposing such things.
Yeah, I mean, it has to be like people has to take care of things now. So what I understand is data science is nothing but the old statistics with Python.
Exactly.
If you have a good knowledge of statistics, and sometimes the degrees are important. So I ask my students now, I mean, all of them, mostly the students, I mean, the speakers from data science are from our department. So they had a hardcore maths background, and then they converted into data scientists. So we have now a good collaboration with them. So we are trying to learn from them, and then we try to convey the information or knowledge to the students.
Okay, sir. Thank you. Thank you all.
Yeah. So that's what. So as I just now mentioned, the participation certificate could be sent. It will take some time, because since from one email I cannot send more than 50 in every day. So as you see that there are more than 750 registrations for this participation certificate. We have to check manually that how many could be considered for significant participation, and then at least 500, I guess. So it will take at least 10 days to send the certificates. So please stay with me. So if not within 1 month, you will not get the participation certificate, and within not by 15 days, the completion certificate of the workshop. Please email me. Believe me, I will try my best. Okay, so any other comments or question? Is Eric there? Eric, let's see if Eric should be here. Okay, any other comments if you have? Rajlakshmi, whether you received this?
Hello, Abhishek.
Yeah, could you please join to the valedictory session? Are you in a position to join?
I am on the hospital.
Okay, okay.
That's the problem.
Yeah, I understand, but please be there with Lena. But
yes.
you are on a speaker, so everybody can hear you. So is it fine? Everything is fine?
Yes, it is fine.
Okay.
But, there were problems with so I had to go to the hospital.
Okay.
And I was unable to find a computer there. So
okay, no problem. But everybody is listening you. So please say something.
Oh yes. Well, again, I would like to be with you, and now I'm on the hospital, and yes, I wish to say my thanks for this wonderful conference, and again, Lena wishes to be there also, and was unable, but I'm very glad and proud that my daughter could come, and yes, again, it has been a marvelous experience, and I thank you so much for this. Yes, well, that is what I can say at the moment. Yes.
Okay, and wish birthday wish to Lena.
Yes, yes.
Today,
And,
how she is doing now? She is fine?
yes, yes. Lena, kan du säga ett par ord i alla fall? I think she can say a couple of words here.
Okay.
Jo, men säg bara att du ville ha varit med. Vad sa du? Säg att sen hälsa dem bara.
Ja. Men ser någon bild?
Nej, det är ingen.
Nej.
Okay. So wish you, Lena, wish you.
Hello.
Yeah, Lena,
Hello.
wish you a very happy birthday, and we are at the end of the conference and we miss you a lot. So next time we will surely having you, and we wish
Yes.
wish
I'm so sorry I missed this
yeah,
time, but that was nothing that I could do anything about. I'm seriously ill, and I suppose Eric has told you. So I've had the vessels transformed in my left leg. So it's at the moment not sure how it all will end, if I lose my foot or it will sort of take over the circulation. It's hard to explain what has happened, but something happened with the circulation and the vessels in my left leg, and now they have taken vessels from somewhere else in the body and transformed to my leg. And for the moment it seems positive, but you can never know.
okay. So we hope for the best, and wish very early recovery of your health, and be back with us next year maybe. So
yes,
okay.
I hope so. And I would like to send my regards to your mother and your son.
Okay, thank you.
And wish them a happy Christmas and a new year.
Okay.
Yeah.
Okay, then bye. Okay.
Pardon?
Okay.
Yeah.
Okay. Bye. Okay, so Carl and Eric Trell, Dr. Eric Trell. So he is by profession, he is a physician, but he is actually a mathematician now. So both Eric and his wife, they are closely associated with our NGO, and of course, Carl is here. Carl is also very close to our NGO. So we all together work. But she is very ill. She is from Sweden, so she is now in hospital. So every day, Eric did a tremendous job at the age of 85. So can you believe that? So that actually motivates us to work hard even. Okay, so if you have any further comments, please let me know, or that would be the end of this session and also the conference. And we'll again come back soon with maybe new ideas, with new activities. Wish you all the best. The Merry Christmas to you all, and coming year, would be even better, and wish you a very happy new year in advance. So see you soon then.
Thank you.
Yeah. Thank you. Bye-bye.